Hello grade 12s, welcome to my channel, and today we have a date with the devil. Okay, this paper is the real devil. You will find out as we go through it. We've gone through portions of this with my students, but I'm going to complete it for those who probably won't be able to attend the class when we finish off this paper. And even for you guys to review this at a later stage if there are some areas you probably want to hear the repeat of what we did. Otherwise, guys, good luck for tomorrow. I normally do not post a video on the day before the exam, but I felt that this paper is worthy to showcase just in case some issues here that kind of really put us on the wall may find yourself being put on the wall in the exam tomorrow. Since paper 1 was quite fairly easy a paper it was, paper 2 is likely to be throwing stones at you. So I need you guys to be ready for stones and to know how to dance with the devil, right? Right. So this, in my opinion, guys, is a higher grade paper, straight up. I haven't found a question here that looks standard grade purely. Yeah, of course, in a high grade paper, there were some standard grade questions, but usually everything was inclined onto the higher grade side. So this is the Northwest, guys, 2024 trial paper. So as you can see, I got the copy from Memo Physics. So go and get a copy for yourself and enjoy this ride with me, bumpy as it is. Okay, now let's get to instructions, folks. It's very important to read all instructions, but I will zoom in onto the main ones that tell us exactly how to behave when doing calculations and stuff. And of course, guys, remember that anything, theorem, law, whatever, if we have used something to determine our answers, we almost have to show that, okay? But again, read all the other instructions carefully and making sure that you understand them. All right, now let's get to the question. So question 1 is statistics. Okay, right. Usually easy stuff, right? So we are told here that the Rugby World Cup of 2023, during the Rugby World Cup of 2023, the ages in years of the players of the Springbok rugby team, goodness, these ones were the best. And in fact, they are really making us proud despite the challenges our country is facing of corruption and criminals at the highest places. But these guys are just making it look so nice and beautiful. Anyway, let's hope they continue to do so. Otherwise, what hope do we have? Nothing. Okay, the data is represented in the histogram below. Okay, so we recorded their ages in years. So this means, guys, whatever we're going to solve here, it is safe to kind of round off to the nearest year because we're talking about years, not months, days, minutes, seconds, milliseconds, and tenths of a second, whatever you want to call it. So we don't want to go there. So we just want years. So most likely every answer that is going to come in years, we need to at least try to get to the nearest integer here. Right, if we look at the histogram, guys, it certainly gives us what we call grouped data. Okay, it's more like a frequency table that we often get. Right, but this time we're not given the frequency table. We are given now the histogram, but essentially both summarize grouped data. Okay, so that's it. So we can see, guys, that the first class here is from 20 to 24. And we can see that the next is 24 to 28. So they are all equal in terms of intervals. They are intervals of 4, each one, all the way. Okay. And then we will see that the first one, we know that the top is the frequency of that class. Right? And then the next one is 8. The next one is between 16 and 14. But since we are talking frequencies here in terms of players, we can't have a player and a half. If it is between, it must be at 15. See, this is the first stone the devil is throwing here. Right. I'm not saying the people who made this paper are the devils. I'm saying the paper is the devil. Okay, get me right. So the devil is throwing punches already from just the graph itself. Okay, the next one, if we read it across, it's a 6. Okay, and then the next one, which is the last one, is exactly 2. So we can multiply that by 2 so that we can see that it's for 2 separate classes. Okay, that's good. And then, guys, what are we supposed to do now? We just answer the questions. Okay, so 1.1 says, how many players were in this rugby squad? So we just add those frequencies. This times 2, we add to that, we add to that, we add to that. Okay, so let's see what happens when we do that. So it's just going to be 2 times 2 plus 6 plus 8 plus 15. We get 33. So this is 33 players. Right. So all we did here, we just added all the frequencies. Right, as you see the circles that I put in there. Okay, right. So we go to 1.2. This is for just 1 mark. 1.2 says we need to calculate the estimated mean age of the rugby players. Obviously, with grouped data, what we normally do, we find the midpoints of each class. Once we do that, we then multiply by their corresponding cumulative frequency, not cumulative, but corresponding frequencies. And then we divide by the total number of these players that we have, right? So basically 20 to 24, this is 44. We add the 2. 20 plus 24 is 44. Divided by 2 is 22. And then we add 24 and 28. So we get 52. 52 divided by 2, that's 26, right? And then here we get 28 plus 32, that's 60. 60 divided by 2 is 30. We can almost tell that the pattern here is increasing by 2 from the lower limit. So this must be 34, this must be 36, okay? But again, guys, you can just do the physical calculations, but we know that this is going to be the case, okay? Right, so all we do, we just multiply by the corresponding cumulative frequency. Not cumulative, again, I'm saying that wrong word. We're going to multiply each midpoint by its corresponding frequency. Then we divide by the total number of these guys. So this is going to be x equals this long, lanky business right here. So the first one is going to be 22 times 2. Add 26 times 8. We add 30 times 15. We add 34 times 6. And then we add the last one, which is 36 times 2. We divide this by the total number of these guys, so we can see that our x bar is the answer thereof. So let's get to business. So we do it. So this is 22 times 2. Please, guys, be meticulous. Don't rush this. It can go very wrong, so you don't want to make a mistake unnecessarily. So this is 30 times 15. Make sure every entry is precise and it is as you have written it out. Sometimes write this out. Don't just do this in the mind. You will be surprised how many mistakes you will collect in just doing this by the head. Yes, it's important to engage your brain, but do not do it to the detriment of your things, okay? Do not allow yourself to suffer, okay? I beg you guys, it's dangerous, okay? It is very dangerous to do this. So make sure, Okay, guys, I'm still entering. I'm still entering things. Okay, something happened here, and then I started punching stupid things. You see, talking and doing is bad for business, ne? It's definitely bad for business. Let's see there. You see now, where did my bracket go? My goodness. It's gonna make me calculate crazy things here. Yeah, actually, see what I did here. I wrote 36 instead of 38. Goodness, you see now. I tell you guys, mistakes like to find you. They just like it. See, I was gonna continue with the mistake if I didn't spot it. Can you see that little mistake of messing up my calculator kind of protected? This is what I'm talking about, that when you do this in a hurry, you will come up with the wrong answers, guys. So this is 29,76. Obviously, this is the age. So in years, this is nothing but 30 years of age. Right, remember, guys, sometimes sticking to how these ages were presented in years, it is safe to do what I just did. But you may still present the answer like that. That's not a big deal. So we get a mark for the method and we get a mark for the answer, whether you gave it there or you rounded it off. It's not a problem. If you round it off to the nearest, it's good. Or if you leave it with the decimals, please make sure you adhere to the general instruction. Of course, if there's nothing else here that is presented, okay? 1.3 says we need to use the histogram to complete the cumulative frequency column in the answer book. Luckily, we have it here, so I'm going to go and fetch it. Okay, guys, so here's our cumulative frequency thing is. So we know that the first cumulative number is the first frequency. Then we add the next one for the next one. It's a 10. We add 15, 25. We add 6. It's 31. We add 2. It's 33. The good thing is that the total of our frequencies was 33, right? So that total should be equal to the last cumulative frequency. So if that is the case, we know we've done this thing correctly. So we get ourselves an easy 2 marks here. Okay, so we've got here, the next one is 1.3.2. This one says we need to draw a cumulative frequency graph, or the so-called ogive. Okay, right. Remember, the pronunciation comes from its origin. Where did it originate from? So an S-shaped pattern in France or in French, they call it's an ogive. Ogive. The G is quite soft. So essentially, when we Anglicize this, we say ogive. Okay, good. Hope you understand why we call it an ogive, not anything else. Now, we need to draw the graph, or the cumulative frequency graph thereof. Again, we've got the grid from the answer book. So we're going to do that. Okay, guys, so here is our grid. So this is very nice and very easy. So now when we draw an ogive, what is important is to ground it. So the best way to do it is to take the lower limit of the first class. That would correspond with the cumulative frequency 0. Otherwise, we always take the upper limits and their corresponding cumulative frequencies. So this is what we're going to do and plot on our graph. Okay, good. So let's do it. So at 20, we are grounding this. But now before we start doing the plotting again, we need to check from 16 to 20, how many ticks? 1, 2, 3, 4, 5. So this means this is 1 unit essentially. So this 16, 17, 18, 19, 20. And then on the vertical axis is from 0 to 5. So this is 1, 2, 3, 4, and then 5. So essentially this means this is 1 tick. So again, this is nice and easy. So we are ready to draw. So we did that, and 24 went with 2. So there's 2. And then 28 went with essentially 28 goes with 10, right? We saw that. Okay, and then our 32 goes with 25. 32 to 25. Okay, that's a big jump. And then 36 with 31. So there's 30, 31 is over there. Okay, so it's starting to slow down or to level up, and it's exactly the shape that we expect. And then 40 with 33. So this is 31, 32, 33 over there. And then of course this thing needs to be a nice and smooth S shape. So it has to be a smooth curve. So we can do that. Okay, there it is. Again, let's just accentuate. Let's accentuate our points so that nobody misses them. I don't know, this guy's making noise with his bike here. I don't know what is cooking. I don't like noise, you know. And especially noise like that, because why is he revving this bike like that? Now this reminds me, I want to take a ride today. It looks nice and sunny outside. So let's move here. Maybe I can take a break, but yeah, guys, I don't know. Should I do the whole paper, just do the stats, post it, and then you look at it? But too many videos are too much sometimes, you see. I don't know. Let's just go. I'll see how everything is going. So there's our O-drive, guys. It's nicely done. So we get our 3 marks there on offer. No issues about it. Of course, where's the mark allocation is grounding it, the shape, and the points that we plotted. So that's how we score our 3 marks over there. Okay, nice and easy. Now folks, I would like to say, if we call this one 1.3.2a, I would like to add a question and say, what is the modal class of the data? This one says use the ogive to motivate for your answer. Yes, so the examiner has the right to tell you what to use instead of whatever. Sometimes when the question just says whatever, then you can use whatever, but this time we have a clear directive. We need to use the ogive here. Let's say you only saw the ogive. How would you know? Now the logic to this is to use tangents to each class. So the tangent to each class is like that. And if we draw perhaps a tangent to this one, it's almost exactly that line, it seems. And then the tangent to that class is over there. It's less steep. That is less steep. So the one with the steepest gradient tells us that that class would give us the modal class. So our answer here is very easy. It is going to be x less than or equal to 32 according to our cumulative frequency, what, greater than 28. Okay, that is our model class. Why? Because it has the steepest, or one can say greatest gradient. Sometimes you can say gradients because that may still be curving, but those ones are the biggest compared to the others. So that's how we know. So we look at the steepest gradients here. They are the way we know that this is essentially the modal class. And essentially, guys, this would correspond, just to elaborate a bit further, this would correspond to the class with the greatest frequency on the histogram or frequency table. Okay, right. So I need you guys to remember this, that we can actually use the histogram for this or the frequency table. But remember, on the frequency table, we focus on the frequencies here. Okay, and of these frequencies, 15 is the biggest. So the one with the biggest frequency or greatest frequency is the modal class. So if nobody said what we must use, we just do that. And then on the histogram, we'll see that's the tallest bar that gives us this. But here we were told specifically to use the ogive. So be particular about how you answer the question. Okay, guys, very important. Just wanted to add that because sometimes these are small things that can actually give you more marks. For this one would essentially get the mark for getting the class and for justification. So easy 2 marks there. Right. The next question says, write down the estimated median. So now this is 1.4. Now the estimated median, again, we're estimating it. So for the median, we just take, on the ogive, we take the number of these, we divide by 2. So this is going to be 33 divided by 2. And then this gives us a 16.5. Now, remember here, we don't have a frequency or a cumulative number, that is a decimal. So in essence, we can round up to 17. Now we take this to the graph. So we start here, 15, 16, and then 17 is over here. Take it all the way to the graph. Now as it hits the graph, we then take it down. Let me just get a nice vertical line. Okay, so we take it from the graph down. So there we are. So we can clearly see that this is almost 30. So we can say approximately 30, right? Because again, we saw that those numbers were in years, so we can't say comma this, comma that. So here the estimated median is, say, approximately 30 years of age. Right, nice and easy. And we've shown how we did it on the graph. Sometimes you may reference that and say, see the ogive. Okay, nice and easy, guys, nice and easy. How many marks was this? 2 marks. Usually for the method on the graph and the final answer. Good. So the next question is 1.5. Now 1.5 says, it was discovered that the frequency of the age data for K players or player, okay, in the modal age interval was recorded incorrectly. The mistake is corrected and the frequency of 2 other intervals are increased. Okay, now the number of players of the squad remains unchanged. So we still have 33. Now determine the minimum value of k if the data of the new histogram is symmetrical. Think now the main thing here is this part, symmetrical. Now what does symmetrical mean? It means it's normally distributed. Meaning there's no skewing here. No skewing. Okay? So this is when we find that the mean of the data coincides with the median, which is Q2. Do you see? Our mean was approximately 30 and our median is 30. So this is basically what this is saying. Okay, guys. So if we look at this quickly, you will see that this one is already good and that one. They are equal on either side of the midline. The ones that are not equal are these ones. So it means we need to think about adding something here as well as adding something for these to be essentially equal. Okay. So this is what we need to do. Right. More like something like this. So we add something there, but we add more here because we can see that we are going to take this one down by some k number of people. So when you take it down, we're going to add unequally to those two classes because those are the immediate ones that are not balanced. And if we can balance these, we can get our normal distribution curve here, which is that bell-shaped curve. All right, so now guys, this one requires trial and error, unfortunately. So from 15, we minus 1. Is it 1? So we can't split 1 into half and a half. So it's not going to work because we need to add to both. They both have to increase. We can't say we're going to add to this one only. So 1 is not going to work. So let's say 15 minus 2. Will 2 work? But now if we add 1 to the other one and add 1 to the other one, this one goes to 9 while this one goes to 7. So they are still unequal. So that's not what the examiners are suggesting. So 2 doesn't work either. So 15 minus 3. We say now, okay, we're going to add, say, 1 to the other side and then 2 to the other side. We still get to 9 there, but 6 plus 2 is 8. So they're still not equal, so it's not going to work. So let's say 15 minus 4. Let's say we add 1 to the other one and add 3 to the other one. So this takes us to 9. 6 plus 3 goes to 9. Perfect. So this is, as you can see, guys, we started from the smaller values and going up. So this is the first value that actually worked because we can still do 15 minus 6 and we unequally add 2 here. This takes us to 10 as it is, and then we add 4 here. It takes us to 10. Can you see that balances? But 6 is not the smallest. There's 4 before 6. So the minimum here is going to be 4, of course, through trial and error. Through trial and error, we can just say k is equal to 4, right? Players or whatever. Right. This is when we see that through, what we can say, through trial and error, focusing on the two paramedian classes. Okay, this is x less than or equal to 28 greater than 24 and x less than or equal to 36 greater than 32. All right, so when you just say paramedian classes, not classe, paramedian classes, my writing, guys, yo. 2, focusing on the 2 paramedian classes to make them have equal frequencies to achieve symmetry. Okay, guys. Sometimes I know this is ridiculous because, I mean, think about it, guys. 3 marks and answer only is not quite an appreciated issue here. Because, yes, if it was 2 marks, but 3 marks is a bit of a lot. So sometimes, I guess, trying to explain the logic behind what you did, it's the fairest thing you can do, you know. Is the fairest thing you can do just to justify, but I don't know. Questions of this nature are usually not so easy. So I would say 2 marks for the troubles of trial and error. And of course, stating exactly why we chose those, because we were told we need to have this data symmetrical, meaning it's normally distributed. Okay. Somebody may even ask a question and say, comment on the skewness of this data. Obviously, it is normally distributed, meaning not skewed at all. Okay. So folks, this is our 13 marks in the bag if we didn't miss anything or mess up anything. Okay, as we can see, this question was certainly a higher grade question because some people forget about trial and error. They think we will always just know some clear method. No, sometimes trial and error is the way to go. So higher grade questions, guys, are not really too bad. They just sit on the very little basics that you folks ignore and take for granted. That is where you get caught pants down. So don't do it. So question 2 says, Mrs. Muchini wants to use mathematical modeling to predict the final results, okay, of her grade 12 mathematics learners. She decides to use the preparatory and final mathematics examination results from the previous year, meaning she is using the previous year's results to try and model something for the matrics of this year. Now, to help her in developing such a possible model, okay, she records in the table below 10 learners. Okay, very important. The totals, guys, are key. So how many learners? 10. Okay, and these are results in percentage. So you can see that these are whole numbers. So again, here we may want, whatever we calculate or estimate, probably take it to the nearest whole number, right? Seeing that this is the case. But again, there's nothing wrong in following the general instructions here. And of course, this is bivariate data where we talk about the correlation coefficient. Okay, very important stuff. Now the question says we need to determine the equation of the least squares regression line. So this is the barb and flace of this question. So anyone who fails it must die, okay? My hands must just reach out of the screen and grab your neck. Kuze kuphele ubomi ngoba hayi awudeserve ubomi ungakwazi ukucalculate that question ube use-student se-maths ne siyaxabana mina nawe. Okay, guys, we go to mode and then we choose stat and then we choose a plus bx. We see our 2-column table. We fill it in nicely, not in a hurry, ne? Meticulously so. So 38 followed by 65 followed by 78, 23, 67, 93, 39, 83, 51, and 66. Now we've got 10 entries there, so we can move on to the next column. Please, guys, make sure that this is perfect because any mistake here goes unnoticed, okay? It goes unnoticed. So 38 went with 57, followed by 72, 81, 27, 59, 94, 41, 85, 54, 79. Again, I've got 10 data entries. So we hit our AC button, it stores our data. We then start shift button number 1, choose regression, we choose A. So our A here comes up as 10,85 to 2 decimal places. Remember, A here is not any of those values, so we can leave it as a real number. B is also a real number. So we repeat the process, shift button number 1, regression, then we choose B this time around. Now to 2 decimal places, this is 0,90. Therefore, we write our equation. Remember, the Y here has a cap or an accent. So this is going to be 10,85 plus 0,90x. Notation, guys, is very important. Please do not distort the notation for your CAPS curriculum. If there's anything you want to take from the exam guidelines, it's things like notation. How it is presented, this is how you should present your answers. All I can say, guys, guidelines are very important on areas of controversy. But standards, there's no question about it. Okay? Anyway, this is what we do, folks. Calculator work, each one of these is a mark. This is a very cheap 3 marks for students. Okay? Now, 2.2 says, a learner obtained 46% for the preparatory examination. Now we need to calculate the possible final examination. So that's a prediction here. Results that Mrs. Muchini can expect from this learner. This is easy. Now remember, the instruction says we need to show what we have used to determine our answers. So we write our least squares regression line because we are about to put it to use. So this implies that our Y with the cap or accent is 10,85 plus 0,90 into 46. We substitute that. So then we can calculate the answer here. Usually, as I said, I would approximate it since the answers of the final examination were whole numbers. Let's go for it. So this is 10,85 plus 0,90 into 46. So we get 52,25. So this is rounded off to 52%. But again, guys, you are at liberty to leave the answer at 52,25%. It's not a problem. Right. So the method, the answer. But remember, we always need to show what we have used to do our predictions. Do not get lazy and just start substituting. I know I'm also a victim of that crime. But remember, guys, for the finals, it is important to not mess up anything. And again, can you see another mistake is incorrect labeling of the questions. So this is 2.2.1 from 2.2. Now 2.2.2, we need to justify issues now. It says, is the answer in question 2.2.1 a good indication of the expected final examination? Motivate for your answer. Now for me, guys, my students asked me a question about the correlation coefficient here. Are you allowed to use it for this question? For me, guys, you look at the question and try to decide what does it want. For me here, this is a general question of saying, can we trust this answer? It's a matter of a yes or a no. And I can say for free, this is a yes. Why? Because if I look at 46, in terms of my domain, 46 is greater than 23, the minimum value, and is less than 93, the maximum value. Can you see? 46 is within the domain, and we call this an interpolation as opposed to an extrapolation. So we can say yes, because we are doing an interpolation. So the prediction is we can just say the prediction is an interpolation. If you just want to know what that means, it just means it's a prediction of a variable within, is it within or within? Within the given domain. Now remember guys, we always say an interpolation is inherently an accurate prediction or a valid prediction. Now for me, R comes in when we want to talk about the strength of our conviction that this works. Now when we have to grade this, it can be from poor to moderate to, very strong and strong. So those are the things that we need to play around. So for me, I listen to the question. It's not about the strength of our conviction. It's whether we are convinced or not. And the reason for this conviction, at least at the basic level, is that we are doing an interpolation, which is inherently an accurate prediction, as opposed to an extrapolation when we predict a variable outside the domain given. That would essentially be an inaccurate prediction because there's a lot of factors that can influence that variable, as opposed to the ones within the domain that we can study and be sure that we've corrected for all the confounders and stuff. And now we know that there's nothing else interfering. But outside this, we cannot predict what could interfere. As a result, that is inherently inaccurate if we're doing an extrapolation. So obviously, folks, we get a mark for our choice and for our justification. I think this is the answer. And then if somebody asked a 2.2.3 and said, comment on the strength of the correlation of the two variables. You can say X and Y. Right. The short answer here would be, this is a strong positive linear correlation. Right. So this is very important. Strong positive linear correlation. Why? We can even justify that R. When we sort R here, we go shift 1 regression and we choose R. R comes up as 0.94. Okay. So this for me is a strong positive linear correlation. Why not very strong? Because if we round off to 1 decimal place, this still doesn't become 1. It just becomes 0.9 because 4 is an insignificant figure. Okay, we can't round up from there. But if this was 9.5 to 9.9, when we round off to the nearest, if we round off to 1 decimal place, that would effectively go to 1. Now that's very close to 1. Hence we say very strong, but this one is strong. But again, guys, there's a table that essentially explains this as to when do you say weak, when do you say moderate, when do you say strong, when do you say very strong. I'll try and look for it and share it in the group, of course. But those of you who just watch this from outside our group, just seeing this on YouTube, please go and have a look at that table somewhere. Find it. This is again some of the things you would perhaps want to look at from the exam guidelines, because these ones can create controversies if interpreted according to your thinking rather than the standardized way of doing it. Okay. So very important extra question there, guys, to consider. And as I would put some asterisks, is that because you've got to check. So your homework here is to check. How do we comment on the correlation depending on certain values? please do check that. But my logic would say if this 4 is insignificant, if I round off to 1 decimal place, this would not take me to 1. So this is not as close to 1 as possible. So I wouldn't say very, but I would rather say strong. And for this, guys, you get 1 mark. Okay, a very difficult 1 mark to get to, because you can see here some thinking needs to come in. Okay, let's do the last question. 2.3 says the point x bar, which is the mean of the x values, is to q, lies on the regression line in question 2.1. Okay, good. Now it says only one of the options below correctly reflects the value of q. Write only the letter and the correct option in your answer. Okay, we'll look here. We'll see that the square root of the mean doesn't mean anything in our theory of this thing. But what means something is the square root of the variance. Now, what is the variance? Is the sum of essentially the x values minus the mean all squared. When we take the square root of the variance and then we divide by the number of these things, we get what we call the standard deviation. So not the square root of that. So that doesn't mean anything. But the sum of the y values divided by 10. Now we had 10 data points here. So this is nothing but the mean of the y values. And we know that this is correct because by definition, the least squares regression line, it is the line that passes through the point where the x value is the mean of the x values and the y value is the mean of the y values, which is the y bar. So by definition, this is good. So the answer here is B. It's not the standard deviation of either ones. So we can write here B. And we get our good 1 mark. Again, guys, this emphasizes the fact that we need to know things for what they are first, then understand their utility in this big whole. And then we can apply our knowledge every time we need to. Otherwise, guys, this is a very nice 8 marks if we did not make any errors anywhere, which is very possible. But remember, we need to limit this by checking our answers for some meaning and correctness. Okay. Now let's get to the real maths, which is analytical geometry. Analytical geometry is essentially going to be the grade 11 moved slightly to the grade 12. Okay, this question reads that in the diagram, A is a point in the first quadrant, B is a point in the second quadrant, and O at the origin are vertices of triangle ABO. Where is it? All right, so there's our triangle. Remember, when something is mentioned, guys, we need to attach some importance to it. It won't be mentioned for fun, okay? Now we're told that F is the midpoint of AB. So there is F, the midpoint. So this means we can just say the x value is minus 3 plus 3 is 0, divided by 2 is 0. And again, it's on the y-axis. 6 plus 4 is 10, divided by 2, that's 5. Okay, we can find those coordinates easily. And this is joined with D. Okay, that means we have a line DF now, which we've got points on either side because that's the point right on the negative x-axis. So we can find the gradient of that line. Okay, the angle of inclination of FD is alpha. Again, it's indicated. So that means we can find the gradient and then work out alpha. The lines AO and DF intersect at E. Okay, there it is. So that's the point of intersection. So we have the coordinates axis to Y. Now we need to think about how we're going to find those coordinates. Now a quadrilateral PQRS. Okay, this is where it is. This one is drawn with QR on the x-axis. So this means R here is some x value and 0, as well as Q is some x value and 0. Okay, good. And S is a point on OB. Again, there is point S, so it's some x value and some y value. And then the side QP is produced to B. So this means we've got a straight line here going all the way. But now we don't know whether this straight line is skewed or not. There is not enough information on it. One thing for sure, we've got some X value and some Y value there. Now the question is, what can we do with this information? We already saw that we can use B and A to find F, which we have. We can also use these 2 points or any combination of the two to find the gradient of this line. And since the y-intercept is there, the y-intercept is going to be a +5. So we can have the equation of that line. That's about it. Then we look at AO. We can see that we've got 2 points here. At the origin is 0 and 0. We've got -3 and 4. So we can find the gradient of this line. And in fact, A in relation to the origin is just going to be 4 divided by -3. That would be the gradient. And if we want the equation, it's going to be basically -4/3. So I think we can write that AO as a vector on the Cartesian plane is going to be y equals -4/3x. I think this is worthy to think about. And then we look at OB. Again, OB as a vector on the Cartesian plane. Since this is all the way to the origin, the gradient is nothing but going to be 6 divided by 3, which is 2x. Since there's no, we can say the y-intercept is at the origin. So that's something to also consider. And then what else can we do, guys? We can find the value of alpha, obviously, by using the gradient of df. And from there, we can also find the equation because the y-intercept is the same as 5. And that's about what we can do. So all these other points remain questionable so far. So once we have so many question marks, guys, it helps to skim and scan the questions just to see where is the information. And in fact, we also don't know enough about that quadrilateral. So we need to find out, because all we know is just it's a 4-sided figure, but we don't have enough information. So those remain elusive. Now let's see. Calculate. So again, it's a very clear instruction. Whatever we do here, we need to show a calculation. Coordinates of f, we can do it. Gradient of df, we can do it once we have the coordinates of f. The size of alpha, take it from the gradient of df. So those questions are nicely scaffolded. They start from the top to bottom nicely. And then we need to write down the equation of OB. We've kind of done it. Give a reason why df and OB are parallel. So that means the gradients here. From here, if this is 2, this is suggesting that we must be having a 2. So we need to think about gradients. Right? Nice. And then we can handle that. It's not a problem. It's 1 mark. So it is given that PQRS is a square. That's the piece of information we're looking for. Okay. I think that part is dirty, so it refuses to highlight where I need to. Okay, if this is a square, guys, this is nice now, because we know that this angle is 90 degrees, and that angle is 90 degrees, that angle is 90 degrees, that angle is 90 degrees. So this means this line is going to be parallel to that, and not just parallel, but equal, because this is a square. All the sides are equal, and the opposite sides are parallel to each other. All the corner angles are 90 degrees. Now, if this is the case, since we're told QPB is a straight line from this statement, so it simply means the coordinates of P, the x-coordinate, is going to be the same as the x-coordinate at B. Likewise, Q is going to have 3. So this also gives us now the coordinates of Q indirectly. Okay, so this is good. This is good, guys. So again, this saves us a bit, but we don't know. Okay, this is a bridge we're going to cross when we get to prove that EDOS forms a parallelogram. Again, these two are going to be the higher grade questions here. We always have them. We always have them. So again, you decide as a student that, okay, out of 18, do you want to score 8 and throw away the 10? Or do you want to make some dent into those questions as well so that you can score some marks and perhaps walk away with more than 50% of this question? It's up to you guys. But at the same time, you want to look at the time. You don't want to sit on these questions and lose time. Okay, now let's start answering. So 3.1 with 3.1.1. Now, here guys, we cannot write answers only, even though the marks are 2. The statement that governs everything here says calculate. So we need to see a calculation. We can't see by inspection here. It's not allowed. All right, let's get to business, guys. We want the coordinates of f. So we know that f is the point such that the x at A plus the x at B divided by 2 is to the y at A plus the y at B divided by 2. Okay, so this implies that our f is going to be, we substitute, minus 3 plus 3 over 2 is 2, essentially 4 plus 6 over 2. You can say therefore our point f is going to be, this is going to be 0 and 5. Nice and easy. So we've done it, guys. It's a calculation. We needed to show that we actually were calculating. An answer only is not acceptable here because the instruction is very clear. Okay, so let's get to the next question. So we've got 3.1.2. This says we need to find the gradient of df. So now that we have the coordinates of f, this is going to be easy. It's going to be y at f minus y at d divided by x at f minus x at d. Again, a formula needs to come up. Right, and then y at f is 5 minus 0 divided by 0 minus 5 over 2. This is just going to be 5 over 2 like that. Now, we know that this is going to flip and multiply the numerator. 2 times 5 is 10, divided by 5 is 2. So this is good. So can you see the gradient of df is the same as the gradient of OB? That answers the next question somewhere down the line. Okay, good. Now, with substitutions and answer. We can't get a mark for the answer only, guys. It's dangerous. So let's look at the next question. 3.2. This one says we need to write down the equation of OB. So nobody cares how we do it, but we just need to find it. So here, an answer only is what is needed. If you start writing other things, you may be punished because the first thing you write is going to be the one that's marked. And if you start singing, you lose marks here, unduly so. So be very careful. Whatever you write, make sure it ties up to the answer. But my advice is a question like this that says write down, do a side calculation on the rough work and then plug the answer, because nobody cares how you got to it. In case you start presenting things that don't make sense, then you lose that mark, and yet it's a very easy mark to score. Okay, this one says give a reason why df is parallel to OB. It's because the gradient of df is equal to the gradient of OB, which is equal to 2. That's why. Get a mark for that easy one. And then we get to 3.4. Now, 3.4 says, if it is given that this is a square, now we already know. Now it says the area of this square is 9x squared, square units. Now we need to find the coordinates of point S. And as you can see, guys, it's not a walk in a park. This one kind of twisted our necks with my students. So, yeah. And again, the error here, we kind of named this X and we ran into big problems because there's a few controversies that come in here that we didn't make up for. So luckily, guys, immediately after class, I sat down, broke my neck, even some more, and the answer just dawned to me that, okay, all right. And the good thing is that that answer kind of led to this one nicely, because we also got stuck when trying to jump into that one as well. So now this is a good revision session even for you guys, because I've got answers that I initially didn't have for this question. Right. This also underscores the part that says there are no ready-made answers for everyone. It's a process, okay? You just have to be brave. Take your time sometimes when you need to. All right, so let's deal with this question now, guys. What are we going to do? We know that essentially, if this is a square, we understand that BQ is going to be perpendicular to the x-axis. So what does this mean? It means essentially, we can just say let the coordinates of, in fact here, I think it's safe. We can easily say the coordinates of Q are going to be 3 and 0. Remember this one says calculate the coordinates of S, but at this point it's a determination here. We're not going to show a calculation because we still have a lot to do here, so this is safe. That is the case because the x at B must be the same as x at Q for a vertical line. Here we can easily just justify this by saying properties of a square. If you don't want to write it, you just write a nice box like this, and then you just show that all the sides are equal. And maybe you can show that the angle is 90 degrees, at least one. That's how you write stuff, okay? So that's the first thing that we've done, guys, okay? So what is the next thing that we want? We can say safely that also we were told that the area of PQRS is going to be equal to the side squared. Now we can choose a convenient side. Since we've got the coordinate here, we can choose QR. We can say that it's going to be QR squared. Okay, that's by definition. So this implies that 9x squared is equal to QR squared. Therefore, it means QR, when we take the square root, is going to be 3x. Okay, this is what we know. Now, what does this mean? This, therefore, tells us that the x-coordinated R is going to be the x-coordinate at Q3 minus the distance, which is 3x, right? So that's what we're going to have, minus 3x, because we kind of made a mess here, because this x is dangerous. We can't just play around that x carelessly. What we needed to look at was to see that actually Q is going to be 3 minus the distance of RQ from the equation. Then it will tell us the coordinates of R. And if that's the x-coordinate of R, what does that mean? We know that, again, S what is a vertical line. So this gives us the coordinates of S in a way, because point S becomes crucial. Why? It will give us a chance for simultaneous equations, because we can define these coordinates of S in terms of R, right? And at the same time, we can also showcase the coordinates of Y in terms of the distance itself, because if this is 3x, this is also 3x, this is also 3x, and that is also 3x. So we're going to play with those values there. I know this one was a crazy question. In fact, it's a higher grade question with an asterisk. It's not so easy. You don't see it coming. So in the Northwest, they like these higher order questions. I have seen that they are higher order questions. Yeah, they're typical of the old higher grade, because there, guys, sometimes you toss back and forth. Sometimes it feels illegal, but it works. Okay, so this is the x-coordinated R, guys. And what does this mean? We know that the x-coordinated R is the same as the x-coordinate at S, ne? Yes. this becomes the same as the x coordinate at S. So we can say safely here, technically, therefore also, I'm trying to think now, what are we going to do here? If this is the case, we can say therefore the x at S as well is going to be the same as 3 minus 3x. That one we are safe. So this is what we want to say. Okay. Now we're going to go on and say, however, Hyman, right well, winner. However, what, mister? We know that S, maybe I should have written the coordinates of S, essentially, because look, that 3x is the 1. Maybe let's just say, therefore, S is the point. Maybe let's just write it in point form, because I want to derive some nice simultaneous equations. This is equal to 3x, isn't it? The y value of SR is exactly the y value of, the value of SR, which is 3x, is going to be the same as that. However, we know that point S itself, we also know that S lies on OB such that y is equal to 2x. Okay? So this is the case. And if this is the case, so it means our y value, so therefore the y value at S is also equal to 2x. Now this is where it gets nice and tasty. It gets very nice and tasty. All right, okay, all right. So we can see what's cooking here now. Now, guys, the challenge is to now solve the problem. So how do we solve for x? This is very interesting, is it not? We now need to solve for x here. I'm trying to think now. Do we really have to explore this and say perhaps the x at S would be perhaps x? Hey, this question, guys. Yeah, this question kind of broke our necks, and I don't want to have my neck broken again, you know. I don't want it. It's not good. It's not right. Okay. So anyway, folks, what we need to do here, the simultaneous equations that we need to do are these ones. We're going to take the y value according to what we found. This is the y value that we found. Right. And then that same y value, we are going to equate it to this one. Right. But this one is going to happen when x is this value. You see, this is very crazy, guys. It looks like you're going around in circles. It's madness. Because now I think that's what's going to help us. Because what we did before, we came close to the answer, but it was a bit illegal because the x's we chose were random, and yet this x here is quite specific. Now let's see what happens. We're going to say this is the case, right? Okay, maybe let's not say this what. It implies that this is the case. But now what was the y value there? The y value at S, when we take that point S right here, so this implies also that 3x is equal to 2. Now x in there, when we've got 3x, what is the x value? is 3 minus 3x. This was the devilish part. This was the devilish part. It took me a while to really get around this. All right, so let's think about it now. And I don't want to make a mistake because precision here is key, guys. One silly mistake, we are out. So this implies that 3x is going to be equal to distribute. It's going to be 6 minus 6x. Then we move the 6x to the other side. We get 9x is equal to 6. We divide by 9. We see that x is going to be 6 over 9. 6 over 9, 3 goes twice, goes 3 times to 9. So now this is units. Or in fact, x is an x coordinate, so we can leave it like that. Or we can say units, or whatever it stands for. So that is x. Now, if x is that value, right? So what should be the x coordinate now? We can say, therefore, the x coordinate at point S is going to be essentially, or even point R if we will, is going to be 3 minus 3. Instead of x, we put 2 over 3. Okay? Now the nice thing is that this will take that, and then we end up with just 3 minus 2, which is 1. Okay? And that would mean the y value at S is going to be, now let's see, the y value there is going to be, I mean, we could have used any R or S, so I'm choosing S because it's the one that kind of helped us to get around here. Otherwise, the other points were not going to be very friendly with us. Okay, so the y at S in essence is going to be 3 into 1, isn't it? So, because that was 3x, right? And if we look at 3x is basically, we take that 3x, I almost made a mistake. So we take that 3x and then we put the value of x. So this is 2 over 3. Very important to keep that. So again, the magics happen. So this one is 2. So precision was key here, guys. Yeah, I've never seen a crazy thing like this. Recently, of course. But back in the days, yeah, there were questions that I couldn't solve. Even my teacher couldn't solve. And for a long time, we couldn't have solutions. Until we do this twisting and turning, which is what is happening right here. Which almost feels illegal. But remember, guys, if you're doing the right thing, just go for it. And the nice thing is, if this is right, this question is going to confirm it because it is scaffolded to it. Okay, so you can say, therefore, the coordinates of S is 1 is to 2. Okay, that looks realistic looking at the position, although this is not so good. I mean, if, for example, my next point is 3, this is 1, so it makes sense. And then if that point is 6, this is by far quite a distance, so that could be a 2. I mean, on a proportionate scale, that makes a bit of sense. So we can accept that answer without questioning it much. But yeah, the devil was here, folks. The devil was here. We needed to know what to do here and be careful. All right, folks, that's not a big deal. Let's see, what is the story now? There's a lot that we had to do. So to get this was important. And perhaps to write the coordinates of S like that the first time around. And then to write the y value in terms of this equation was also key. Right. And then to substitute these ones into each other was also key. Oops. The devilish step. So there's 4 marks already. And then we can say solving for x was probably not important, but solving for the x value there, that's 1 mark, and solving for the y value. But remember, the question said coordinates. We need to present the ordered pair. If we don't, we lose the last mark. So this one was, these are questions as well as when you've gone, but you know what, in maths, guys, it's okay. It's horrible. Anyway, that's just maths, guys. You just have to do it, okay? Now let's do 3.5. Now 3.5 says prove that EDOS. So where is that? Now let's just highlight it nicely, a different color. So ED, so E to D, and then we go to O, and then we go to S, and back to E. Right, so there's our quadrilateral as well. We now need to prove that this is a parallelogram. Obviously, we already know that this side is parallel to that side from question 3.3. So our task is to now prove that this side is parallel to that side. Okay, it's crazy, né? Because that's what we can do here. All right. Okay, all right. Or the other thing that we can do, remember, for a parallelogram, there are many ways of killing that cat. If we find these coordinates of E, since we had a plan of how to do it, we can then find the midpoint of this line, perhaps. If we can find the midpoint of this line and then draw another diagonal and find that its midpoint is the same, so we will have proven that this is a parallelogram. As you can see, guys, time gets chowed here trying to structure this answer, because it's not questions that you can just flow through all you want. So there's two things here. It's either we prove that these two are parallel. How can we prove that they are parallel? We can just prove that the y value of E, either way, we're not going to escape the coordinates of E. If we can prove that the y value of E is the same as the y value of point S, then that would place E and S to be on the horizontal line. And a horizontal line is parallel to the x-axis. That is sorted. Or we find the coordinates of E and then we start looking for the midpoint of EO. At the same time, we look for the midpoint of DO. If the midpoint is the same, it means the diagonals of this quadrilateral bisect each other at a common point. So we've got all of that to do, and which is not so difficult after all. So the first thing, find the coordinates of E. The second thing, we can look at the midpoints of the diagonals. If it is the same, then good, it's a parallelogram. Or we prove that point E by just calculating point E. If the y value of point E is the same as the y value of S, that would place it as a horizontal line. A horizontal line is parallel to the x-axis. So I think that one is the first one and is the quickest one. So choose the quickest way and we sort this out. So we're going to say, first of all, point E is a point such that, perhaps let's start by saying, what do we want? We say OA as a vector on the Cartesian plane is such that, now here, this said proof, so this we can do by inspection, is such that y is equal to minus 4 over 3x. Right, this is by inspection. We don't want to waste our time here. The second thing, we already now know did we know? No, we don't. We want to find out the equation of df. We can say likewise, df, we calculated the gradient of df. Now df as a vector is such that y is equal to its gradient, that was 2x, but the y-intercept is already given. So we write that. We can say, but we know that point E is such that 2x plus 5 is equal to minus 4 over 3x. They are equal. That's the point of intersection. Do you realize it was stated? And then we move things around. Okay, we can take this to that side. So we can say minus 4 over 3, minus 4 over 3. Let's go to computing mode. Minus 4 over 3 minus 2. What is it giving us? It gives us a minus 10 over 3. Okay? And then this is equal to 5. So let's see what happens. Therefore, this x here is going to be basically 5 divided by minus 10 over 3. So at times just use the calculator to avoid being overwhelmed. So the x value here is minus 3 over 2. Okay? So that would be the x value at E, and therefore the y value of E, we can substitute this into any of the equations. So when we do that, we can just choose the easiest. So this is minus 4 over 3 into minus 3 over 2. Right. So what happens here? 3 takes 3, 2 takes 2 out of 4. Then the negative times the negative, we can see that this is basically 2. And yes, this already confirms that ES is a horizontal line because the y value at E is the same as the y value at S. And so that proves that that is parallel. And therefore, this becomes a parallelogram because ED was also parallel to OS from those big lines DF and OB. So from here we can say, well, therefore the y at E is equal to the y at S, isn't it? Equal to 2. We can say, therefore, that line ES is parallel to the line DO. These are horizontal lines. Right. If this is the case, guys, maybe... Okay, let's just move on to the next page. It's not a big deal. From here, guys, we can conclude that since, we can say since ED is parallel to OS, we can say from to, what is it, 3, from 3.3 above. Okay, we can say therefore EDOS is a parallelogram. We can say the pair of opposite sides are parallel to each other. Okay, so a pair of opposite sides are parallel to each other. So obviously, guys, whenever we prove something, there must be a conclusive reason. Can't just say it and then... So as you can see, it's not so easy, guys, but it's not so difficult after all. So obviously, folks, for me, the method of solving simultaneously is more important. And essentially, this conclusion is more important. And essentially, that conclusion, very important. Now, the other marks, guys, is the examiners who can decide where they come from. But I think the key step was to find this value. I think that was important. But since we are using it to make our deduction, maybe we can say the substitutions here, perhaps. It's quite a haphazard way of doing things, but those equations are effectively given. But this one can be considered because nobody asked about it. We can perhaps move the mark into it. So this one is the quickest. Otherwise, to take it a step further would be prolonging the inevitable. Okay, guys, so those are good, because if this proves this parallelogram, it means we are correct here, no matter what the memo says. So whatever the memo will come and tell us, if we proved S to be that value such that this came out to be a parallelogram as well, then we know that we are not wrong about those coordinates. Okay, sometimes this also helps to kind of cement the fact that whatever you feel you've been doing, because it sounds illegal, that whole shenanigan and gymnastics, they look and feel illegal. But if the next question essentially confirms that, then it means even if the memo has a different approach, which probably makes more sense, if we got the right answer that is proved by the next one, I mean, would that be a coincidence at all? I doubt. Okay, so I doubt that would be a coincidence. Okay, guys, so let me just go and drink something quickly, and then we move ahead to doing, oh, by the way, how many marks were there, guys? Let's sum it up. So this is 18 marks if we did not create any issues for ourselves. So as I said, guys, those two questions, okay, the first one is one that is a higher grade with a star, because even higher grade students would stumble across that one and perhaps not do it right. The first attempt didn't work out, even for me, and it took the second attempt. Right, this one is a standard higher grade question, because once we've sorted 3.4, it becomes easier to sort 3.5. Okay, now let's move on to the next question, guys. I just need to eat something before I continue. I'm feeling a bit weakish. In fact, I couldn't sleep, so I've been up, guys, since the last time we did our tutorial together, so I couldn't go to bed. I kept tossing and turning. Then I decided to sit for this one, and ndayikokotela yaze yaphuma, because ngimkokoteli ke mina. Don't call me a genius, guys. I'm a fluke. Ngiyakokotela ezami izinto ngama-phone call. All right, so let me charge my tablet at the same time while I eat something. Maybe I may even wash my bike so that I can give this one enough time. Because my fear is that as I continue with this paper, if the power gets cut, my tablet may end up not being user-friendly at all. And that means we'll lose this recording. So let me take it the safe way. Okay, so I'm just going to spend some time, maybe 30 minutes, to allow this to fill up a bit so that we can take it to the finish line. Otherwise, go and drink some tea as well. And let's carry on thereafter. Okay, guys, so let's just carry on. To wait until this is full, it's not gonna happen. Time is not on our side. Okay, question 4 reads, in the diagram below, the circle with center P has this equation. And obviously we write it in the standard form. It's gonna be x minus half of the coefficient of x all squared into y minus half of the coefficient of y. That's going to be 4 squared equals. Now this is 80 plus. Remember, we're going to square the 2. It's going to be 4. So it's going to be 84 plus 16. So that goes to 100. Okay, so this is good. And then QS is a tangent that touches the circle at Q, so it means this is a tangent, so we know that the tangent is always perpendicular to radius. Right, and intersects the x-axis at S, so we can find the coordinates there. It's going to be some x value and 0. And point R, which is 10 is to T, lies on the circle, so it means we can just substitute x as 10 and solve for y. So this is very easy. Okay, so what about the center now? So we can see that P maybe let's write it outside. P is going to be 2:4. Okay, good. And then we know how to find the coordinates of t by just substituting that point into the circle, and we solve for y. And we can find the equation of the tangent. From the equation of the tangent, we can work out the x-intercept. Okay, so this one looks okay. We can do pretty much everything. So let's just go through the questions without any difficulty. Determine the equation of the circle in the standard format. Again, if it says determine open-ended, we can do it by inspection and not explain what we did. So what I'm going to write here is just that it's going to be x minus 2 all squared plus y minus 4 all squared equals 100. So we get a mark for the left-hand side, we get a mark for the right-hand side. Okay, so 4.2 says, write down. Again here, no explanation, okay? 4.2.1, answer only, even. The coordinates of P, no explanation why. So this is 2:4. So the reason is because the center is those values with the opposite signs, okay? Those values inside the brackets with the opposite sign. 4.2.2, we want the equation of QR. Now the equation of QR, what we notice about it is that the x value at Q is the same as the x value at R. So this makes this a horizontal line. Okay, so if this is a horizontal line, so that means essentially QR is going to be defined by where it cuts the x-axis. So this is going to be x is equal to 10. Easy one mark over there. So let's go on. So we've got 4.2. Now 4.3, sorry. So 4.3 says, determine the equation of the tangent QS. This is the standard question, so it's not a problem. So we know that essentially the gradient of PQ times the gradient of the tangent should be equal to -1. This is because the tangent is always perpendicular to radius. Now this implies that, okay, we've used this formula, or we haven't, so we can say this is y at Q minus y at P divided by x at Q minus x at P, all multiplied by the gradient of the tangent. It's going to be -1. We substitute. So y at Q is 10 minus y at P, that's 4, divided by x at Q, that's 10 minus there is 8, into, we can just say times the gradient of the tangent is -1. So I will often just reveal the answer here in case I need it for the following questions. So this is 6/8. So this becomes 3/4 times the gradient of the tangent. So we can say therefore the gradient of the tangent is going to be the negative reciprocal of that. Right, so we flip that. It's going to be -4/3. We can say then, we know that QS as a vector on the Cartesian plane is going to be y is equal to 4/3 x plus c. Now we've got point Q, 10:10. Then we've got 10 is equal to 4/3 into 10 plus c. Therefore, C is, so this is basically 10 plus 40 over 3. This gives us a 70 over 3. So therefore, y is minus 4 over 3, x plus 70 over 3. Great stuff. So that one is very easy. So essentially this gradient, this rule, maybe we can say substitutions here, and then this gradient is good, substituting the point and delivering the equation, proper stuff. But sometimes this may be entertained, but I think it makes more sense with the substitutions and all. We still have to justify why we decided to use that equation. We're not thumb-sucking it, we are using a theorem. All right, so that's easy, guys. Nothing really out of the ordinary about that question. So 4.4 needs us to find the size of RQS. So the size of RQS is this one. So RQS is that one. Okay. So this is easy. RQS needs us to focus on this triangle. So if we look at this triangle, RQS with this side RS extended to the origin, we can see that that angle that we're looking for plus this angle here, which we can call theta if we like. This angle we can get by using the gradient of QS, but instead choosing the absolute value of what we get. Although we could use the outside angle, but since we chose to make the 90 degrees that side, so we can do that. So essentially this is good. So we can easily say here, well, in triangle RQS, first and foremost, we know that the tan theta is going to be equal to the gradient of QS. So this implies that tan theta is going to be minus 4 over 3. Therefore, theta is going to be essentially the absolute value of the arctan of minus 4 over 3. Right. So this is equal to, so arctan of minus 4 over 3 gives us a minus 53. So when we take the absolute value, this is going to be basically 53,13 degrees. All right. So this is the value of theta. Sometimes you may write here and say, let QSR equal to theta, because we can't talk about tan theta that we don't know where it came from. Okay, so that's the first thing. We can say then, we already know that technically this theta plus the angle in question RQS should give us Q anyway, guys, we're gonna just say 90 degrees. Let's not complicate our lives. 90 degrees. And what is this? This is the exterior angle of triangle. Yeah? That's the exterior angle, so we don't need to complicate at all. So this is 53,13 degrees plus RQS equals 90 degrees. Therefore, RQS is going to be 90 minus 53. So this is 90 minus 53,13. So this gives us 836,87 degrees. Nice and easy, not complicated at all. So this is just 3 marks. So we get a mark for this. We get a mark for perhaps the substitutions, but perhaps more on the reason and the final answer. Okay, not a complicated question. So let's do 4.5. 4.5 says we need to calculate the area of PQR. Okay. So that is that triangle. And obviously, for us to use this effectively, we need the coordinates of R in 4. Okay. So we can say here, basically, the circle equation, we saw that it is x minus 2 all squared plus y minus 4 all squared equals 100. And then we can take that point R with 10 and t. It will be such that we've got 10 minus 2 all squared plus t minus 4 all squared equals 100. Right, we sort this out. 10 minus 2, that's 8. 8 squared is 64. Plus this one we leave as is to avoid trouble. So this implies that this t minus 4 all squared is going to be 100 minus 64. Okay. So this is 100 minus 64. This gives us 36. Okay. And then of course we do the gymnastics here, inverse operations to then isolate t. So this implies that t minus 4 is going to be plus or minus 6, isn't it? Right, so now let's think about it. What are the values that we're looking for? This is a positive value for t. No, we need a negative value for t. It can't be positive. We can say therefore t, because it's a point in the fourth quadrant, so the y value must be negative. So we can say therefore our t here should be, we take the negative 6, then we add 4, we get minus 2. Okay, so t is minus 2 there. Otherwise, if we chose the positive 6, it would give us 10. And that's not where it is. Okay, that can't be 10 in the fourth quadrant. So we can see that, okay, t is like that. And therefore we can say, therefore point R is 10 is 2 minus 2. Very important. Now folks, there's a few techniques that a student can use. For me, I know this is a vertical line. So if I draw a horizontal line perpendicular to that vertical, right, this would give me the height. And the nice thing is that that height is the x value at R minus the x value at P. So my students chose to use the sine rule, the area rule instead. That's not a problem. That's not a problem, because how they did it, they knew that the radius is a 10, right? The radius is a 10, square root of 100 here. That's a radius. And they worked out this distance QR. And from there, they worked this angle. Okay? PQR. Then they used the area rule by using that radius and this distance, okay? But any of these techniques should work. So let's deal with this issue nicely. So we can see that, okay, the area of PQR now becomes easy. We can just say then the area of P triangle PQR is going to be half base times height. Okay, so this is equal to, here you can even say C sketch. Well, sometimes you just want to make constructions and not say a lot. So this is half. If we make the base QR, it's going to be the y top minus y bottom. So y top minus y bottom is going to be just 10 minus minus 2. So this becomes plus 2 into, and then the perpendicular height is going to be the difference of the x at r, which is going to be 10 minus the x at p, which is minus 2. So let's sort this out. So this is 0.5 into 12 into 8. So we get 48 square units. Okay, nice and easy. We get 48 square units. Right, of course, guys, you can go through the long route, seeing that that angle is 90 degrees, and we calculated this angle to be 36.87. We can work out that angle because those are complementary angles. Once we have the angle, we use this length, we use that length, we use the sine of that angle from the area rule, and we get our answers nicely. Otherwise, in the interest of time, I'm not going to waste it on that. So obviously, guys, substituting this point and finding the t value, and then here we can say substitutions and all those values inside, and the final answer with the right unit of measurement, square units or unit squared. Excuse me. So we are sorted there, guys. So let's get to the next question. So 4.6. Now this is another devil in this question. In this question paper, this is the devil. Higher grade. Because you can see sequences and series are coming in. Again, this one gave us a bit of a choke slam. But yeah, after sitting down for a second, again, it started to make sense. And I'm going to explain exactly what this all means. Now, the story says a function h is formed by restricting the range of the circle to y greater than or equal to 4. Now, we kind of had a bit of a struggle figuring this out. But what is of note, guys, is that this situation right here, you see already we know where 4 is. So it is here at point P. So this is right in the center. So if we produce this line all the way to the circumference, and we take this line across all the way to the other circumference, this becomes the equator. Okay? This becomes the equator through which we are restricting this graph. Now we are literally restricting this graph into this semicircle above. So this is essentially the equation of the semicircle, that h. Bear with me for a second because I want to highlight this nicely. Okay, so it kind of wanted to ditch me a bit there. So this is this semicircle that we are trying to restrict this graph to. Now, the equation of h is the equation of the semicircle. At first, we even chose the wrong position, I guess. Right, now look at this, guys. From the center, P, this is the radius. So this is 10 units, and this is also 10 units. Now, if we take 10 units back, so 2 minus 10 takes us down to essentially minus 8. So we didn't need all those crazy calculations we ended up doing. So if we do this again, we will see that from 2, we move 10 units ahead, we get to 12. Okay, so this is what we have. Those are the x values at those points when y is going to be a 4. Okay, so these are on the x-axis, so we can showcase like that. All right, so how do we find the equation of a semicircle? We know that in this format it's much safer, as it is with the equation of the circle that is at the origin. So this one, we're going to say find the equation of the circle in general, of a semicircle in general. We are going to transpose this side because we want to solve for y, right? So we transpose this to the other side. So we end up with y minus b all squared equals r squared minus that bracket x minus a all squared. Now we want y, so we take the square root on each side. So please guys, pay attention to this. You never know when it's going to come to haunt you. This is going to be y minus b equals, now when we take the square root, we say plus or minus the square root of r squared minus x minus a all squared. Now we want to isolate y, so y is going to be, we transpose b, it becomes a plus b plus or minus the square root of r squared minus x minus a all squared. So technically the equation of this semicircle, if we look at it, because this is now the function of h, so h of x is going to be equal to, we take the value of b. Remember it was minus in the equation, so this becomes 4 plus or minus the square root of essentially 100 minus x minus 2 all squared. But the most important is that if we restrict it to the positive portions, so it means we're choosing the positive square root instead of a negative square root. So this is the function of h that we needed. Okay, so that's h for us. Very important to think about these things. Okay, so that if it is needed, then we handle it. Now, this question says, if the sigma of these x values, when we plug them into h, from minus 8 to 2. So what does that mean? It means from here, we are taking all these values all the way to p. So essentially, this is a quarter of a circle, if we think about it. If we split this by drawing a vertical line here, so if we split here by drawing a vertical line all the way to the circumference, we will see that this splits our semicircle into quarter circles. And what we are doing here, if we're substituting the x values in h, so these are essentially the y values. This is the y values of h added for each corresponding x value. Okay, so this is what this means. So don't be scared when you see sequences and series, but try to find some sense, which sometimes doesn't come early, but it can come eventually. Now we can see that we're taking from minus 8 to 2. So this means we're adding all these y values, but remember with sigma notation, we only increase by 1. So we're going to choose the integer values of x. So basically we're taking the integer value of 8, which is going to be 4 here. And then we are also taking the next integer value, say minus 9. We don't know where it is. And then we're taking this other integer value and so forth. Okay, guys, so this is essentially what this is doing. Okay, all of these, we're taking all of them. I don't know why I went all the way down. It shouldn't. It stops at the semicircle. It doesn't go all the way down. Okay, let's just remove this. So we're taking all those integer values of x and calculating the corresponding y values. And those corresponding y values are these ones here and there, and of course I'm just taking a few. And we're adding all of them up until that one. Okay? Right. And then we're told that those y values add up to k. Right. Now we have to determine the value of the x value starting from 3 all the way to 12. Okay. So now if we look at it, 12 is here as well. Remember, we got 8 here and we got 12 there. Right. Where our circle ends, or the semicircle ends. So this is the domain of the semicircles. Now, we need to start from 3. Now, this means we're going to ignore the 2 here. Then we're going to start from 3. Say 3 is over here. So this is 3. Okay, let me write it differently. This is 3, and then we want this corresponding y value. Then we're adding all of these ones from there all the way to 12. Okay, guys, they may be looking a bit diagonal or skewed. I'm not going to care to correct them. So we're going to add all of them up until the 12th one, which is 4. Okay. But now here's what is important. There is a gap that shows up here. Of these integers, the gap that shows 3 and 4, can you see this becomes a full quarter circle? Essentially, that becomes a full quarter circle. But with the other one, if I can highlight it differently. So with this one, it's not a full quarter circle. It starts going like that. So it leaves this gap to guesswork, so to speak. So there's this gap here that we need to consider. But if that gap is to be considered, we get another full quarter circle. So meaning this whole thing plus this whole thing, when we combine everything, they should sum up to the same value, because these are both quarter circles. So each integer value of x will give a corresponding y value that's the same, because it will be the mirror images of each other. So essentially the sum here should be the sum on this side as well, from 2 to 12. So that means from -8 to 2, we should get the same sum as from -2 to 4. Okay, so which means that would be also k. But if we start from -3, then it means we will have eliminated the x of 2 here. Right? So we will have eliminated the x of 2. And now we know that on this semicircle, the x of 2, remember the radius is what? 10 units. So if the radius is 10, remember this dotted line there is 10. So 2 plus 10 takes us to 14. So we know that when x is 2, our function h is going to be 14, because it's just directly above 2. And that's what we neglected in this expression. But if we consider it as a whole expression from 2 to 12, then we subtract that of 2, then it leaves us this quarter circle here that we are looking at. So this quarter circle eventually is what we're going to end up working with. So this is a bit of a complex question, but yeah, it is the devil in the house. Again, I would put an asterisk here. It's not really a standard higher grade question. This is one of those that tend to take you a bit across. Okay, so obviously from seeing that visually, then we start to understand that, okay, taking integer values of x from -8 to 2, and those sum up to a quarter of that circle. Again, from 2 to 12, that would be the same quarter circle. And essentially, they are mirror images of one another. So we should get the sum from 2 to 12, as well as from -8 to 2. Then we will see that this one started from 3 instead of 2. So that means we just take away when x is 2 in h. So this is very important. So obviously, guys, here's what we know now. We know that essentially the sum from x is equal to minus 8 to x is equal to 2 of our h of x. This is the same as the sigma from x is equal to 2 to 12 of our same h of x, right? Because these are both quarter circles, I would say. Okay? Or we can say they are essentially integer values that would give us, symmetrical y values. So the sum should be the same. Let's just say these are both quarter circles. That would make sense. Now, we have to deal with this. So basically, this then confirms that this part is going to be k. We can say, therefore, the sigma from x is equal to 2 to x is equal to 12 of our h of x must also be equal to k, because we were told that this whole shenanigan is k, right? So this is what happens here. But now, to get that sum of the y values from 3 to 12, it means we're going to have to take away just the sum of only s2, okay? Or should we say x is equal to 2? We can say then we understand that the sigma from x is equal to 3 to 12 is going to be the same as the sigma from x is equal to 2 from 2 to 12 of h of x minus the sigma when we are doing the sigma of x is equal to 2, right? I think we can say that of x is equal to 2, and essentially, okay, maybe let's just say it's only going to be f of 2, h of 2, perhaps. I think that would be best to put h of 2, because we can see that h of 2, once we take it away, then everything else becomes less than the quarter of a circle that we had. So this is a crazy question. It's a crazy question. It's not easy to think about. All right, so what do we have, guys? We can see sigma from x is equal to 3 to 12 is going to be, we know that this from 2 to 12, it came out to be the same as k because it gave us that quarter circle. So this is going to be k minus. Now h of 2 from the graph, we can see that we just add 10 to the circumference. It gives us 14. So we can say that this is 14. And that is essentially the answer, guys. Very nasty question. It's a devil. It's a devil. Is it devil or devil or devil? Yeah, shanya the question, guys. So this one dribbled us as well. But thinking about what needs to happen started to bring the light. Again, guys, work on the sketches, draw things. You will start to see that a whole lot of stuff becomes very sensible once we start doing things, okay? But again, if you didn't want to perhaps use the graph for this portion, use the equation. Use the equation. H of x is going to be 4 plus the square root of 100 minus x minus 2 all squared. That, just substitute x is equal to 2 there, it's going to give us a nice 14. But again, using the graph makes everything simple, but it takes an effort to know sequences and series. When you choose the sum from a certain number of terms, how can we relate it to when we take all the terms? What can we see? What happened? Things like that, guys. Because sometimes we may not know the terms in between. We know that the sum of all terms says 12. But this is the sum of all terms, maybe when they are 14. And then now we say, we want to know the sum of the last 7 terms. we know that it's going to be the sum of all the 14 terms minus the sum of the first 6 terms, isn't it? Because then it would leave us the sum of the last 7 terms. So we're using complementary events, essentially. If you think about it in probability, this one we use complementary events. Once we know the total and we know the part sum, whatever is missing would be the complement. Same stuff right here. Crazy, eh? But very interesting at the same time. So obviously, folks, I think this statement and its reason makes more sense in my opinion. And essentially, this for me would make sense as a result. And perhaps to get this 14, whether by inspection or whatever, okay, maybe this is crazy. This is the final answer, okay? 3 marks, maybe for this one. We can get a mark for that part and say, okay, when you use those complementary events, that is the most important portion here. So as you can see, guys, it looked all too crazy, but it's actually not so bad once we have a plan. Right, so this was a rather painful 21 marks, especially with the last question. Oh, not you doing what I don't like, Wennerman. So why did I have to get to the edge? All right, so those are the solutions to this. So I guess this one makes sense with an explanation, and of course working on the sketch a bit, it starts to dawn as to what is going on. Otherwise it may not make sense on the face value. And I can tell you for free, we kind of struggled to get around this question. Okay, now let's get to trigonometry, guys. Okay, maybe we're gonna start flowing. I don't know, I'm feeling a bit slow. Anyway, guys, I didn't sleep, by the way. I kept tossing and turning, and then I woke up. Then I started to do this paper, but then I kind of enjoyed a movie, but still after the movie, I didn't feel I want to go to bed. So I was like, anyway, let me just do this, especially for those who would not attend, since you guys asked that I record the session. So let's just go for it. Okay, question 5 says, in the diagram below, the graphs of f of x is equal to a sine 2x, and the graph of g of x is equal to 10bx. Okay, so there's been a change of periods for these two functions, mainly. But if we look at the amplitude of the sine graph, it goes to a maximum of 1, minimum of -1. So we know that a is equal to 1. Okay, and then when we look at the 10 function again, you can just think about it. How do we get a b? We know that 10 of 45 should give us 1, but now this is happening at 90. What happened? Okay, so normally we divide by something. So we say former divided by the new one, isn't it? That's what we do always. So we use division. So the former is 45 degrees, and then the new is 90 degrees. And then this tells us this is 1/2. So it means the value of b is 1/2. So it's always like this, guys. So use division for this kind of things, especially with the period. It almost always works. Okay. So that's the quick analysis we can get to here. So P is the point minus 68,53 degrees, not just 53 degrees. Is to minus 0,68. Okay, that's fine. And then Q is the point of intersection of F and G. Okay, so P and Q are the points of intersections. So we've got them. Okay, good. Right, so this is fine, guys. So let's get to business. So 5.1 says write down, meaning answer only. Don't explain. So 5.1.1 says the value of A. So we know that A is equal to 1. But for the purpose of learning, please guys, remember the amplitude is what gives us the maximum and minimum. And how do we get the amplitude? We always say the maximum value minus the minimum value divided by 2. Now we can see that the maximum value is 1. Let me demonstrate this. This is 1 minus into minus 1, the minimum value divided by 2. So this is 2 over 2, which is equal to 1. If at all somebody said calculate, this is what you would have to do. But at this point, we don't need to explain. We just do it by inspection. This helps a lot, folks, when this graph is shifted. Find that the minimum is at 4. The maximum is at 4. And then the minimum is at, let's say, minus 1 plus 3. What is it? Is it 2? Yeah. Find that the minimum is at 2, maximum is at 4. So what do you do? Yes, this is the best way to go about it. Please note it. Because this thing of always guessing values, it always catches up with you somewhere, somehow. So at least at this point, the question was clear. We don't need to explain. But remember, it won't always be like that. So we need to know the method. So for the purposes of teaching, I'm going to show you some skills and tricks as to how to get to business. Right, the coordinates of Q. Now, the coordinates of Q, guys, if we look at the sine function, we know that the sine function is quite symmetrical, just like the cosine function. So if we look at this point, now let me tell you the idea behind all of this. Take, for example, this turning point. How did we move this turning point to that turning point over there? What happened? So there's 2 reflections that we had to do here. First, we took this point and moved it up there. So what happens when the y values change but the x values remain the same? So we did a vertical reflection of this point. Then after doing a vertical reflection, now the x value, which was negative, is now all of a sudden positive. So that means we did a horizontal reflection. So we did 2 reflections here, a vertical reflection, and then that same point, we then did a horizontal reflection. So we do the same for every other point on the sine graph, because these are going to be mirror images of each other in the same format of reflection. So from minimum to maximum, we did 2 reflections. First is the horizontal reflection. Depending on where you looked at this, the horizontal reflection plus a vertical reflection. So every point is like this. It's a horizontal reflection of one point, then which will later vertically reflect, or we can say it's a vertical reflection which will later horizontally reflect. That's how we get the symmetry of the sine function as well as the cosine function. So if we take that point, we vertically reflect it. This becomes positive somewhere there. This remains the same. And then we horizontally reflect. So this would be kept positive, right? And this one will now become positive. So the coordinates of Q is the mirror image. So it should be 68, 53 is to 0,68. Can you see everything is positive now? Because of these 2 reflections. First, the horizontal. Second, vertical. Or you can say first vertical, then horizontal. It's up to you really how you want to look at it. Okay, so again, since we didn't have to explain, we can just write Q is 68, 53 degrees is to 0,68. Right. Now, do you see the importance, guys, of using the semicolon for the coordinates instead of a comma? Because look now, there's a comma there, there's a comma there. You can't have 3 commas here. You'll be confusing us, okay? So please pay attention to notation. So again, guys, if one was to explain what happened, we can say due to symmetry, in the sine, and sometimes cosine functions, right? Each point on the graph is a mirror image of the other, such that two reflections have been made. One, a horizontal reflection, followed by two, a vertical reflection. This is what we sometimes just say symmetry, but you hardly probably, what am I saying? I'm speaking crap English. Usually you hardly hear of how are they symmetrical. We just say it. But the other way of crudely looking at this, guys, remember this is revision session, don't worry about answering. The other way of crudely looking at this, we can say we are moving from a turning point to this. Right? So the same thing here, we're going to have to move the same distance from the turning point to that. So we can just ask ourselves, how many units did we move from 45 to that? So we just say minus 45 minus into minus 68,53. So this tells us we moved essentially 23,53 degrees. So if we moved those units to the left, here we move in the opposite direction. We're going to say 45 plus. So we just take this one, we add 45. It takes us to 68,53. Okay? I don't know what I wrote here. This is 23. Okay. So we just do that, guys. So there's another way. So that's the shortest way of doing it. Or the other way of looking at it is to say from an x-intercept. Okay, guys, I'm showing you all the tricks now. Back to that. And again, we're going to say from this x-intercept back to that. How much did we move? So we can say basically minus 68,53 minus 90. So it's going to be plus 90. So this tells us that this distance is 21,47 degrees. But since this one we moved towards, because these are sort of like symmetrical and they are in the opposite directions. Can you see this is a reflection of this other graph? So here we're going to do the opposite motion. So from here we're going to move back 21,47 degrees. Again, if you do that, you say 90 minus 21,47. We get exactly that 68,53. So I've shown you guys more than one way of handling that business. Okay, please handle it when you get it right. So these are just ways to use symmetry, but remember this is the easy part. But where did it come from? Because we see that these graphs are reflections of one another in a way. So this whole thing, this is its exact mirror image on the other half. So above and below the equator, that's where the symmetry comes in, okay? And then, of course, the period, you know, that this point is going to come back here after 360 degrees. So there's lots of ways to look at these things, folks. Please look at them and look at them good, okay? I need you guys to look at them good. Right. So I just needed my graph clean so that we can use it further if we need to. Okay. So I think, guys, I've given you a very comprehensive explanation just for each one of those coming up positive, and you understand now which reflections took place for us to get to those. Very important. Learn these things and master them, guys. Otherwise, you will be mastered by a subject instead of you mastering it. We need the x values of the turning points of h. If h of x is f of x plus 30 degrees. Now we see this addition of 30 degrees within. We know that this is a translation. Let me write it better. I see this thermophysics thing of too many things in the page. So this is a translation to the right, sorry, to the left. We always do the opposite of what is in there, to the left by 30 degrees. So this means we take the original turning points, we shift them to the left 30 degrees. Now here's the one. We take the x value there, this is minus 45. When we shift to the left, we're going to subtract 45. So it's going to be minus 45, then minus 30. We subtract 30, not 45. It goes to 75. So we're going to say x is equal to minus 75 degrees, or x is going to be equal to, we take 45, we subtract 30, it becomes 15 degrees. Okay, good. So on the physical points, we actually do a subtraction. But on the equation, in the notation, it shows up as a plus. We always act in the opposite when we have to deal with x, isn't it? So those are the two values, guys. Again, nobody asked us how we did it. But for those who are interested in showing everything, you can just say x. The first one was essentially minus 45. Ne? Then we subtract 30 degrees to move to the left, okay? And then the second one here, we know that it was 45 degrees, and then we're going to move it back by taking away 30 degrees. And that's how we end up with those values above, okay? That's the explanation for that, in case you don't remember or you don't understand. So 5.1.4 says, we need the values of x for which g of x is less than or equal to 1. Okay, the graph of g is the 10 graph. So we want g of x to be less than or equal to 1, greater than minus 60 what. Okay, so obviously this is this interval. Basically, it's from here all the way to the end of the graph. So that is that interval. So we can write here x must be less than or equal to 90 degrees, because at 90 it is 1, and before 90 it is less than 1 up until it is greater than that value there. So we can say this is greater than minus 68.53 degrees. So it's that very large interval. Again, this is by inspection. Now, 5.1.5 says we need the value of m. Okay, we need the value of m so that f of x plus m is equal to minus cos 2x. Okay, so this is the sine function. But now we want to make it look like the cosine function. But if we look at m here, m in this equation is a horizontal shift. Or should we call it a horizontal translation? So how do we answer this question? Obviously, we know that a sine graph on the Cartesian plane, if I can draw just a generic sine graph, it's like this, isn't it? Let's just extend the axis a bit. Right. So this sine graph is like that. But if we shift this sine graph, say we shift it to the left like that, so that the turning point is like this, we know that the cosine graph is always symmetrical about 0 mark. So the x-intercept and the x-intercept are equidistant from this point. And this starts at a maximum. Now, when we say this is negative, it means for this to be negative cosine theta, we would have to perhaps shift it like that, so that at 0, we start with a minimum instead of a maximum. That would be the graph of cos shifted like that, or perhaps a cofunction of the sine 2x. So this is what would happen. We would have to shift it like that. But this graph, the way it looks, we need to shift it towards here. So that if we look at this graph, we just highlight it so that we can study it nicely. If we look at this graph now, if we shift this graph to the right like this, so that the minimum turning point is directly across 0, that would be the cosine function. And if it starts at -1, it means we've inverted that graph. So that's essentially the transformation that we need to perform there to answer this question. So we shift it to the right by how many units? Exactly 45 units. Now, remember in the notation, m must be negative so that it can translate to a shift to the right. So we can just write m must be equal to -45 degrees inside the notation, but outside we actually add. So that's another 2 marks. So I love these questions, guys, because they really teach you a thing or two. Okay, so let's go for the last one of these interpretation questions. So 5.1.6, we want the value of b. Again, you saw how we worked it out. We say the former divided by the new one, or the current. Usually we get 10 of 45 to give us 1. Now when that happens at 90, it means we're going to say the original divided by the new one. It will tell us the ratio that should be. So obviously we saw that b is a half. Again, for those who don't understand, we always say, what do we see in the original 10 function? In the original 10 function, remember, it starts off like this, right? And if this is 1, usually this is at 45 degrees. So we know that the former, b is going to be the former value for 1 divided by the new, I guess. I'm going to say former divided by new, or former divided by current. Perhaps let's say current. Now the former is supposed to be 45 degrees. Now the new one, we see that it's at 90 degrees. If at all we were asked to do a calculation. So 45 once, twice. So that becomes the value of b. Okay. I hope we are clear, guys. If the question said calculate, but when it says write down, we just write it down. Can you see it's even 1 mark, but it's a bit more technical than the others. But I suppose it is expected that students would get this one right. Okay, let's do 5.2. 5.2 says, for which values of x in the given interval is x, meaning any x value, now this means it can be negative, it can be 0, it can be positive. Basically, the x-axis as they are, negative, 0, and positive, multiplied by g of x, or by the square root. Now, remember, there's a very important issue with square roots. Of g of x, right, minus f of x. And this, we are saying, must be greater than 0. Now, first of all, with the square root, guys, we can't have a negative. So obviously, for this to never be a negative, it means g must be above f of x. Okay, so this explanation actually came with my students. The way I explained it was rather tedious, but that one, student decided, this one is beating around the bush, let me summarize this, and he summarized it perfectly. So g of x must be above, and this one must be below. Because when we take a bigger value and subtract a smaller value, we always get a positive answer, isn't it? Otherwise, if it is inverted, we get a negative answer, and we can't take a square root of a negative. So basically, for this square root to work, it means g of x must be greater than f of x to begin with, for us to satisfy the square root. That's the first thing. Now we go into that. Let's just remove this. Let's just remove this, okay? Now we look here. When is the graph? When is the graph of, say, g above the graph of f? So basically, guys, it is those areas, né? Because we can see the graph of g appears above the graph of f. The graph of g appears above the graph of f. In these other unshaded areas, it is inverted, meaning what would be under the square root here would be negative, and we can't take a square root of a negative, so it has to be real. So those are the two areas. Now, are they both accepted? Now remember, now what decides that this thing is going to be less than 0? Because we can already see the square root here must always be positive, essentially, because out of a positive square root, we must have a positive answer. So this is forever positive. Now this means for this to be greater than 0, the x values must also be positive. Because when they are negative, it's going to be a negative times a positive, which is a negative. Now a negative is less than 0. It's not greater than 0, and that's not what we want. So because this side, if we draw any vertical line, again, use a ruler, folks. You've got your rulers, just use it. You study a graph from left to right. If we come and park here, what do we notice, guys? The x value on this side is negative. Whereas what comes out of the square root is positive. So this is not going to work. Okay, we move. We get here, we will see that the x values here involved are positive. And now positive times that positive thing is going to give us a greater than 0. So definitely the answer here is going to be, say, less than or equal to 90. 90 is included because the graph of g is still above 90, but greater than the value at q, which is 68,53 degrees. Why are we not including? Because they are equal there, and when they are equal, the difference is going to be 0, and 0 was not included here. So that's how we answer that question as well. So very easy, 2 marks. But again, it needs one to understand a whole lot. Once we put more restrictions, we need to be very careful on how we answer that question. All right, guys, so this is how that thing works. So again, this could be a very, very nice and tasty 12 marks because most of the questions were interpretation, and we have done graph interpretations as best as we could. Sometimes for my students, I always add extra questions, but for the sake of this video, not to be as long as, you know, we all don't want. So let's just get to business and finish this thing if we can as fast as possible. So let's go. Question 6. Question 6 is going to be the general trigonometry, right? Right. Usually this is question 5 and some sub questions, of course. But now we have it at question 6. So 6.1 says, in the diagram, point P is x is to 24, and this is 25 units from the origin. And T is a point on the x-axis such that TOP is theta. Okay, so obviously, folks, our job here is to drop this down to the x-axis, because that's what we do with this kind of a question. Just drop it down to the x-axis, and we know that this would be perpendicular because every point on the Cartesian plane is at a perfect horizontal line from the y-axis and a perfect vertical line from the x-axis. That's how it works. That's why Pythagoras for every point would work even if you didn't draw the sketch. But for the purposes of this, the y value is 24. Then this is the x value that we need to find. Okay? Right. And then, of course, we work it out. So x squared is equal to, x squared plus y squared is equal to r squared, which is from Pythagoras. And x is what we're looking for. This is 24 squared equals 25 squared. Therefore, x is going to be the minus value there. Let's see, square root of 25 squared minus 24 squared. We get 7. So it's going to be minus 7. Right, so this is important, guys. We need to write it down here. So x squared plus y squared equals r squared from Pythagoras. Then this implies that x squared plus 24 squared is going to be equal to 25 squared. Okay, I'm shaking a bit because I'm tired now. X is going to be minus 7. And of course, guys, the sketch needs to come in. Let's just do it quickly. So normally what I do here, I safuna spana nango. Heban. Ke mohlolo jwale. Hey when. Oh, there it is. I don't see. Now my brain is cooked, guys. So I want to take this friend of ours. Come on, when I'm on Bala, Chini. Maybe let's just copy the whole thing. Right. Let's pin it. Sisikuthatha sithi woza. Swagala bese siyabeka lapho. Sithi hlala lapho. Okay, nenkani izawufuna uhlala phi ithanda khona. Right, sithi ke ngokwena, thank you. You've served your purpose. Now what I need is to remove this one. It's no longer needed. And then we move this friend up. Okay, there it is. So we need to do that, guys, and work out whatever we have worked out. In fact, we can make it a bit bigger so that it's easy to see. Okay, so this is fine. Now we can answer the questions. 6.1.1 says, calculate the value of x. So that's easy. We've done it, guys. So this is nothing but, okay, 6.1. This is 6.1.1. So we've done it. So how many marks? 2. So from Pythagoras, we get our marks nice and easy. So 6.1.2 says without using a calculator. See, the restriction is only on this question here. We need the value of 10 of 360 minus theta. So we know that 10 of 360 degrees minus theta, this is going to be equal to minus 10 theta. Now this is going to be minus 10 theta. It's going to be the opposite of adjacent. So this is 24 divided by minus 7. So this comes up as 24 over 7. Nice and easy. So most important is the reduction and the final answer. Okay. Right, so easy. So 6.1.3 says we need to calculate the size of POT, meaning the size of theta. Now the nice thing here is that nobody told us not to use a calculator for that. So we can actually use the calculator if we want. Okay, we can actually use the calculator if we want. Now let's think, what are we gonna do? So we can use any of the trig ratios. For me, I know that sine theta came out to be basically opposite, which is 24, over hypotenuse, which is 25. So this implies that theta is going to be the arc sine of 24 over 25. Right, let's see, shift sine 24 over 25. Now this gives us an angle in the first quadrant, né? Because now this one kind of uses the reference angle, you know. Maybe the best one would have been cos, you know. Let me see if I used cos, what would happen? Say shift cos minus 7 over 25. Yeah, this one is good. So sine doesn't really give us a clear answer because we don't want to suffer. Sometimes we want to choose the one that's going to give the answer. So we know that cos of theta is minus 7 over 25. So this implies that theta is going to be the arc cos of minus 7 over 25. So therefore theta is 106.26 degrees. That's good, but even with the sine, all we have to do is to take that angle from 180 because sine there is being evaluated in the second quadrant. So we'd have to say 180 minus the arc sine of that value, 24 over 25. You know? All right. So it still gives us the same answer. So even the 10 could be used. So anything can be used. And remember, here this time the restriction was only on 6.1.2 for not using the calculator. Others didn't tell us not to. So obviously, guys, this is 2 marks. So I think the method would be good, but perhaps the answer is more important. I mean, this ratio is more important. And the answer, the in-between stuff is just a calculation because we were told to calculate, but yeah, whatever. Now my throat is sore, guys. I'm tired. 6.2 says, without using a calculator, calculate the value of the following expressions. Can you see everything under 6.2? We must not use a calculator. So this means for this as well as that. Right, so let's do 6.2.1. We've got sine 20 degrees plus cos of 120 degrees times the tangent of 405 degrees plus cos of 110 degrees. Nice. So how do we deal with this? Now remember, guys, I told you the procedure. We always reduce bigger angles into acute angles first. Then we follow the strategy later. So sine of 20 degrees is already an acute angle plus cos 120, this is 180 degrees minus 60 degrees. Remember where special angles apply, we do that. So times the tangent of 405, let's see, 405 minus 360 is 45. So this is basically 360 degrees plus 45 degrees, and then plus cos 110. We can also easily see this is 90 plus 30 degrees, is it? No, plus 20. Unfortunately, this one played into the hands of that first one. It would be outrageous to say 180 minus, because we can see that there's an odd one out, so a strategy here automatically kicks in. So this is sine 20 degrees plus. Here, 180 minus 60 is going to be minus cos 60 degrees, right? Into 10 is going to be a positive 10 45 degrees. That's an angle in the first quadrant plus. Now here, cos of 90 plus is going to be minus sine of 20 degrees using cofunctions. Now we simplify further, sine 20 degrees. And then here we will have minus cos 60 degrees times 10 of 45 degrees minus sine 20 degrees. So these ones essentially cancel out. Now we're left with minus cos of 60 is a half, isn't it? And then 10 of 45 is 1 over root 2. Lying, it's 1. It's 1, my lord. What am I saying? Special angles are escaping me. Now, guys, negative times positive is negative, so this is minus a half. So that's the answer. And we didn't use the calculator anyway, right? Right, so for these reductions, 1, 2, 3. How many marks was this? 4 marks. And of course, the final answer. But this should have been 5 marks, because when we use special angles, that's 5 marks. Okay, good. Now the next one is 6.2.2. So we've got this nice expression as well. So we have to evaluate here. So the bracket square root of 2 cos 15 degrees plus 1. This is the square root of 2 cos 15 degrees minus 1 times the sine of minus 2x. So we did this, guys, in the class. Remember that KZN document for revision 2025? This question was there. Okay, so this is what we have, folks. And then what do we do now? Of course, we look and see. This looks like a difference of 2 squares. Remember the 3-step approach, guys. We always try to do inverse operations. So we reverse that. So this comes up to be root 2 squared. It's just going to be 2 cos squared 15 degrees, okay, minus 1. So this is what we end up with. Then this one is going to be minus sine 2x, because sine of a negative angle is going to be negative. Now below we can factorize and factor out a 2. We remain with 2 sine x cos x. Now we can see identities popping up. The first one, 2 cos squared 15 minus 1 is the same as basically cos of 2 times 15 degrees. The cos double angle identity into minus sine 2x all over. Now this one is going to be 2. Now 2 sine x cos x is the same as sine 2x. Now with multiplication, this and that divides to 1. And we continue. So this is going to be cos minus cos 30 degrees over 2. Now let's see what else is there. Now we've got cos of 30 is root 3 over 2. So it's going to be minus root 3 over 2 divided by 2 over 1. So this is going to be minus root 3 over 4. Answer. Okay, now remember guys, here's what you can do to check if there's answers. In fact, I forgot to highlight that. We just put that on the calculator straight away. Because we cannot walk away here with wrong answers. We can actually check. So let's do it. Sine 20, right, plus cos of 120 times the tangent of 405, then plus cos of 110. See, we get minus half. So we know that answer is good. Let's look at the second one. Just do it as we see it. Square root of 2 basically times cos. Okay, maybe let's just say this one into cos of 15 degrees. Right. And then we say this one plus 1. Close bracket. And then we go on to the next one. Again, we've got root 2 into cos of 15 again. Minus 1. Okay. And then all of this is multiplied by sine of, say, now we can give an angle there for x and say it's 2 degrees, or let's just say it's 1 degree. So this is going to be essentially minus 2 if x is 1 degree, okay? Now we need to be careful about brackets. There's going to be too many of them. 4 into, can say sine of 1, because now we said x is 1, times the cos of 1 as well. So this one gives us a decimal. It gives us a minus 0.433012719. Now let's look at this one. Minus root 3 over 4. What is it? Exactly the same thing. It's minus 0.433012719. So this is good. So this confirms that we are winning. So these kinds of questions, guys, you already know when you are doing the right thing and when you are not. Okay. So obviously, guys, doing inverse operations here, difference of two squares, perfect things. The reduction here is good. The factorization there is good. And then using the identity for this one is perfect. And the identity for that one is perfect. So we've got how many marks now? 1, 2, 3, 4, 5, 6. How many marks were on offer there? Just 4. My goodness. This is horrible. Okay, let's readjust. I think though using the double angle identity to 30 is mark worthy. This one is also mark worthy. Maybe we can negate the factorization here. And perhaps we can bunch the reductions together. Okay, and say here the mark is for the reductions as well as the reversal there and the factorization. But when we use an identity as a powerful mark, we use the double angle identity there. Again, that's a mark. And then we get to this one. Okay. Crazy though, it should be more marks, but yeah, it is what it is. Okay, so we didn't use a calculator, we used everything that we know. Okay, let's get to 6.3. 6.3 says, excuse me, x we need to, if sine x plus y times cos x plus y is equal to t. Now we have to express the following in terms of t. Okay, let's copy it. 4 cos of 90 degrees minus 2y times cos of 2x plus 4 sine 2x times cos of 360 plus 2y. Okay, so what do we do here? Again, following the three-step approach, guys, we first deal with brackets. Brackets off, isn't it? So this is equal to 4. Now cos of 90 minus is going to go down to sine 2y. Okay, times cos 2x plus, we've got 4 sine 2x. Now cos of 360 plus, it's the same as cos of 2y, isn't it, in principle? So it's the first quadrant. Now we can see that, we can see something. There's a common factor of 4 here. So we take out 4. We end up with sine 2y times cos 2x. Plus, we can just start by saying cos 2y, because we can see this is like the sine compound angle identity, sine 2x. Right. So this is good. So we've got 4 into, we shrink this. Now when we shrink it, it's going to be sine of the first angle, which is 2y, plus the second angle, which is 2x. Okay. So this is identities at play. So this is 4 into, again, we can take out the 2 as the highest common factor there. So we're going to have sine of 2 into essentially x plus y. We can change the order so that it looks like that. Right. Now after this, we know that this is the double angle identity. So we've got 4 into, we can expand this. So this is going to be sine. If we say sine 2 of this is going to be basically sine of x plus y times cos of x plus y. Then we redistribute the 4. By the way, I forgot here. There's a problem. There is a problem, so we should have 2. Okay, it looks like everything is getting messed up now. So this is 2 times the sine of x plus y as the angle, and then there was a 4 outside. Okay, so this is good, guys. So we then multiply in again. So 4 by 2, that's 8 sine of x plus y times cos of x plus y. Now we're told that sine of x plus y times cos of x plus y is t. So this becomes 8t. Quite an interesting identity there, or question. Essentially, this is simplification of an expression, but yeah, took a lot of things. But again, if you remember the three-step approach, you can see how effortless I did this without even thinking too hard sometimes. Okay, there are moments where you can't just do this easily, but there are moments when you can. But if you don't have a strategy and you don't have a template to work with, you will always suffer, right? Right, remember this one. So obviously, guys, how many marks here? 5. Okay, let's see. For me, this reduction using cofunctions was key, and that reduction using same function was key, right? 2 marks. I do believe that the other mark is when we shrink this to this one using identities. That should be the 3rd mark. And then when we factorize this into the double angle identity, but I think the double angle identity expansion here, that should be the 4th mark. And the final mark is the answer. Okay, that looks okay. Now let's get to 6.4. So 6.4 says, given that given sine squared x plus cos squared x plus tan squared x, we now need to prove that this identity is essentially equal to that. So easy stuff. So my students kind of like, this one is easy. I was still thinking, and then they're like, nah, it's over, bother. It's klaar ding. Now, of course, we're going to write here the left-hand side, or maybe let's just write the equation first. Sine squared x plus cos squared x plus tan squared x. This is equal to 1 over cos squared x. Now remember, with identities, we always take the left-hand side if we can, or the right-hand side if we can. So sine squared x plus cos squared x plus tan squared x. Now this is a grade 11 identity, obviously, because we know that sine the same angle squared plus cos of the same angle squared. This is a square identity, so this is 1 plus 10. We can use the quotient identity. So this is going to be sine squared x over cos squared x. Now this is over 1, so we use the common denominator, which is nothing but the LCM, lowest common multiple of the 2, which is when we multiply the 2. So this is cos squared x. Cos squared x divided by 1 is cos squared x times 1 is going to be cos squared x plus. Cos squared x divided by cos squared x is 1. 1 times the numerator is just sine squared x. Now again, we've got a square identity, so this is 1 over cos squared x, which is equal to the right-hand side. Now this is a grade 11 question, honestly, right at this juncture. So nothing really difficult there. So when you put 1 there, it's good. When we use our quotient identity, it's good. And when we use our identity yet again, and that is the 3 marks, because the answer in its entirety was given. So we're not going to worry too much. Okay, so we're seemingly cruising here, but again, okay, that is good. I labeled everything fine. Now the second question, it says, Ati, a grade 10 learner, argues that the square root of sine squared x plus cos squared x plus tan squared x is not equal to 1 over cos x if x is an element of 180 degrees to 270. Now the question says, is Ati's argument correct? We need to motivate our answer. Okay, now this is the higher grade part, but again, even higher grade for grade 11s. So this is a normal higher grade question. Now folks, as I said, with square roots, we need to be very particular. Do you see that the volunteering is a positive square root? So meaning this thing must be positive. Whatever comes out must always be positive. If it is not, it is not representative of what we are given. 2, the denominator must not be 0, because then we end up with an undefined situation, which is not representative of what we are given. So now if we look here, you will appreciate that cos x. Now cos 180 to 270, this is the third quadrant. Ne? This is the third quadrant. Because 180 is here, then 270 is here. Now we can see there that cos is going to be negative. So if this is negative, because we're taking a positive square root of what is inside and it's a perfect square, we can't have a negative. So definitely Ati is correct, because this thing is going to be negative for 180 approaching 270. But at 270 exactly, it's going to be 0. So this will be undefined. So we can say indeed she is correct. So we've got a 6.4.2. We can say, is she correct? Yes, we can say yes. we can say with x an element of course these ones were not included. Okay, now I can see even the 270, you can see here 180 and 270 are not included, but it's any value in the third quadrant. You can say x an element of this round bracket 180 degrees is 270 degrees. We can say here cos x will be negative. And certainly not an answer to the given expression. Right, good. Let's just leave it at that. As long as we stated that the cos x would be negative, and we can't have a negative from a positive square root. So definitely this is good. So we say yes, and the motivation, easy 2 marks. Say something sensible, guys. It doesn't have to be super duper accurate. Okay, let's do 6.5 here. Trig, guys, is very long. Sometimes I would advise students to perhaps start on this question of trigonometry, take it all the way to the 3D thing, because it's not very easy for trig to be rushed. Then the next stop is Euclidean geometry, because you cannot rush that section either. Then decide between analytical and statistics, which one comes first, but mostly analytical because it carries more marks. And then finish with stats. But again, you can interchange depending on which questions you see are easy to approach. Right, so we are given here that 2 to the exponent 2 sine squared x minus 5 times 2 to the exponent cos 2x equals minus 3 for x in the first quadrant. Right. This says show without using a calculator that sine x is 1 over root 2, meaning the value of x is 45 degrees, essentially. Okay, so this is easy. It's an exponential equation. As I said always, guys, trigonometry is algebra, so just know this. Okay, so what do we do here? Well, this one we can't change so far. We can leave it as 2 sine squared x because it's getting us there. Then this is minus 5 times 2. Now cos 2x we can change to 1 minus 2 sine squared x using our identities equals to 3. Then we use further exponential laws. Step 3. So this is 2 to the exponent 2 sine squared x minus 5 times. Now this is 2 to the exponent 1 times 2 to the exponent minus 2 sine squared x equals minus 3. This implies we will see that, okay, minus 2 sine squared x and 2 sine squared x are not the same. So we need to use another exponential rule. So 5 times 2 is 10 times, by the way, we can divide by 2 to the exponent 2 sine squared x. Now when we put it on the denominator, it carries a positive exponent. Right. Now, some students at this stage may opt to use the K method. I don't really like it. So here we just multiply by the common denominator of 2 to the exponent 2 sine squared x throughout. When we do that, we get 2. Okay, maybe let's do it so that we have enough space to write the expression well. I don't know how you guys manage with these crazy dedicated spaces that these examiners are all of a sudden, you know, obsessed. I don't know why these guys are always obsessed with causing problems instead of creating solutions, because this is no solution. It's just punishment and torture to students. Then when we multiply here, guys, we get minus 10 equals 3 times this thing. It's going to be 3 times 2 to the exponent 2 sine squared x. Now we move everything to one side because we can see our nice quadratic coming, right? This one becomes 3 times 2 to the exponent 2 sine squared x minus 10 equal to 0. Now we know that we're in a familiar territory. So I'd like, guys, for you to approach or confront algebraic expressions head on. Stop with this K method things. Yes, there are times where you can use it for substitution purposes and stuff, but hey, get to business right here. So we know that this is 2 to the exponent 2 sine x. This is going to be 2 to the exponent 2 sine x because that's what the square means. 10 is going to be 5 and 2. And the difference gives us 3. Now, which one is positive? Is 5. The 2 is negative. Now, we will know that when we solve this bracket, it's invalid, right? Because there's no way a power can have a negative value. We can't have that. It's unacceptable. So this implies that essentially 2 to the exponent 2 sine x is equal to 2 to the exponent 1. And we can write this nicely. 2 to the exponent 2 sine x cannot be equal to minus 5. It's unacceptable. There's no power, even if the exponent can be as small as possible or big and negative. The whole power can never be negative. Now from here, same basis. So we know that 2 sine x is equal to 1. Ne? Very, 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 very important. By the way, I made a mistake. This is sine squared because remember this was squared itself. So this is still sine squared. Oops. Okay, let me write it properly. I could see that my answer is not going to tie. So this is 2 sine squared x. Remember, if we squared it, was going to be to the 4. So this is still 2 sine squared x. Okay, this is squared. This is squared, and therefore still squared. Okay, good. Now this implies that sine squared x is equal to 1 over 2 when we divide. Then we take the square root, the left hand side, right hand side. So you can say therefore sine x is going to be square root of 1 is 1, square root of 2 is root 2. And in fact, someone may even say prove that sine x is 45 because here this is a special angle. So the arc sine of this, or at least sine of 45, gives us 1 over root 2. Okay guys, this is done. As you can see, terrible stuff. In fact, I'm not even gonna go through when do we get a mark, but perhaps let me try. I think this one is very important. The factorization is very important, and the gymnastic is key. 1, 2, 3, and to write the quadratic in standard form, maybe 4, and using identities 5, and using laws here to split or to change to whatever. Anyway, this mark can be anywhere. Remember guys, with the exponential equations, usually there's too many areas to consider. So it would depend honestly on the examiners. But do your part, show all your steps, and you move on. So guys, this was a very easy 30 marks to score. Nothing really out of the ordinary here. Just needed a student who is prepared. Now let's finish trigonometry quickly. Question 7. Now question 7 says, in the diagram, D, B, C lie in the same horizontal plane and it's shaded nicely. AB is a vertical tower, so if that is 90 degrees, that should also be 90 degrees, right? Because that's still to the horizontal. Okay, AB is a vertical tower, right? The angle of depression from A to C is 30 degrees. Of course, if the angle of depression is 30 degrees, it is equal to the angle of elevation, right? Because those are essentially alternate angles with parallel lines, the horizontal and the imaginary horizontal. Right, we are told here that BCD is equal to BDC equal to 90 minus beta, so already indicated, and AB is H meters. See, very important is that these are meters, not centimeters or units. Now the first question says determine the length of BC in terms of H. So this one is guiding us. Remember, sometimes they may not guide us at all. Okay, they may not guide us. We may just be showered with this question. The strategy will always start with the triangle or any figure that we can see that has at least two angles given and one side. And the second strategy is to calculate all possible angles. So if this is 90, this is 30, this one must be 60 degrees from three angles of a triangle. And then what should this angle be? Because we might need it. So let's say it's going to be 180 minus 180 and then 2 beta. So that one is going to be just 2 beta. Okay, good. So this is what this is going to be. So this is nice. It's beautiful. So we calculate all possible angles, guys, and then we start with the triangle that has the most things. Then we work with it. So essentially, we're going to start here and say 7.1 in triangle ABC. So we know that essentially angle C in this triangle is going to be equal to that angle that was given to us, right? The angle of depression. So it's going to be equal to 30 degrees. So you can just say the angle of elevation is always equal to the angle of depression, because they are literally alternate angles. They are alternate angles with parallel lines being the horizontal. Right, nice and easy. So this is just the explanation in case you wonder why. All right, so that is good. And then we can say, what are we looking for? BC, we know that 30 degrees is going to be the opposite H over BC, which is what we want. We can say, therefore, BC is going to be H divided by 30 degrees. And nobody said, okay, this one says in terms of H. I don't know if there's a need for us to really deal with that 1030, but then 1030 is a special angle. So the side adjacent to 30 is √3, and the side opposite is, 1. So basically 10 of 30 is √3. So we can even go further and say BC is going to be equal to H over √3. Maybe that's safe because we don't want to leave things unsimplified. I think this is good to always do. Just simplify. I'm tired of sitting here, guys. I'm moving. This thing is not filling up. It should be full by now. This is a fast charger, but for some reason it's just moving slowly. Yo, I'm dying. My leg is cramping. Anyway, now I'm seated nicely. So obviously, folks, I suppose this is good, and the answer, we just move along nicely. Okay. Now 7.2 says write down the size of DBC. DBC. Again, you see, once it says write down, it means answer only. And we saw how we could do it. So we know that DBC is going to be 2 times beta. Easy 1 mark. And nobody said we must explain. But if we have to, from sum of 3 angles of that triangle. So we've got 7.3. We need to show that DC is equal to this whole shenanigan. And once you see a square root and you saw something like this, okay, now we are at liberty because we've got this side now in terms of h, and we've got all these angles. So we have this angle and the side opposite that, and then we've got that and the side opposite that. So I think it's safe to use the sine rule here. Although that square root of 12 suggested something like the cosine rule, but again, we need to see a lot of terms coming in. So far, maybe we can get away with just the sine rule. Now we want DC, so we can say, well, in triangle DBC, we know that essentially DC, what we're looking for, over the sine of the angle opposite it, which is 2 times beta. Now I'm moving quick, guys. It's going to be the side BC over the sine of the angle opposite it, 90 degrees minus beta. So this is the sine rule. Of triangles, right? This implies that DC over 2 sine 2 beta. Why did I have 2 sine now? Hey, sine 2 beta is equal to BC. We saw that it's going to be h over root 3. This is now divided by sine of 90 degrees minus beta over 1. So we continue. So this is DC. We use our double angle identities. This is 2 sine beta cos beta equals, this one is going to become h divided by root 3 times sine of 90 minus this is going to go to cos beta. Okay, that's good. And then we move on. So this implies this thing why does it look not right now? Doesn't look right. Okay, let's see, guys. We're gonna have DC coming up as h times 2 sine beta cos beta all over basically root 3 times cos beta. And the cos beta does the good thing and cos beta go away. So this implies that DC is going to be essentially 2 times h sine beta over root 3. Now we can see that, holy cross, there ain't no manga business there. What did we do? It means we rationalized the denominator. So we can rationalize. We multiply by the square root of what we want. But remember, This is on the principle of 1 being the multiplicative identity, because this whole thing is nothing but 1. But it's a strategic type of 1. So this implies that DC is going to be equal to. Now we start doing our things there. So yeah, I'm thinking. But how will I get 12, guys? Because I need 12. Exec 12, man. This rationalizing here is not gonna work. Because this is just gonna give me 3 there. Then the root 3 multiplies that. And then inside I get 6. I'm not gonna get 12. Yikes. So this means it needs a strategy. Can you see, guys? They have come up with a higher grade question. So we need something that we can multiply to root 12. Ne? So if we say root 6, what happens? Yes. We shall see. We shall see. Now I'm thinking of a nice number. Let's say we decide, because remember we can multiply by anything that we want. Let's say root 6 over root 6. Now what happens when we do that? We're going to end up with 2 times... actually I'm wrong. No. This one is good. We don't need to change. This one is actually good. But then there's something that doesn't add up, though. Something is not adding up. Because this is good like this. So we can easily say, well, this is going to be 2 root 3 times h sine b over root 3 times root 3 is going to give us 3. Now this means that DC is, now when we reverse this inside, remember when we reverse this inside, we're going to square the 2. So this means this is the square root of 4 times 3 times h sine beta all over 3. So you can say therefore DC is equal to square root 12 times h sine beta. Now this 3 doesn't go away. So I suppose something is missing here. Maybe. We know most of our provincial papers have errors, ne? So I suppose that should be the one. Otherwise, I don't see that 3 disappearing, eh? I don't see it. So let's just assume, or at least believe, if not, that is the case, ne, guys? Because sometimes mistakes do occur here. And when they do, things happen, okay? So I believe that is what needs to happen over there. Oh, guys, my ear is paining. In fact, I'm feeling like my throat is dry. So this one is a lot. This one is a lot. So, you know, excuse me, guys. But I feel like something is not right, man. Why? 10 people so boldly like this, huh? Did we do the right thing? Let's see. Why do you know root 3? Overlap. Overlap. Tell us, comrades. Maybe I didn't do the right thing, Let's go back. This doesn't make sense. You can see it's not there, man. This thing of always trying to think the memo, always thinking that the question papers are wrong. Yeah, sometimes it's you, which is me this time. I feel like I did some crime. What is 10:30? I just can see jog. I feel like I've done some crime. If this is 30 degrees, the opposite is 1. The hypotenuse is 2. The adjacent is √3. Now 10 of 30 is 1 over √3. Oh my goodness. Okay. That's the one. So that's the one. The mistake is here. You see, double check, guys. When things don't tie up, double check. Don't just think you are right. So this is 1 over the square root of 3. And this essentially flips. So therefore BC is going to be √3 times h. Okay. That was my mistake. I almost blamed the examiners, as we always do, and yet the examiners did no wrong. All right, okay, so these steps need to be sorted now. Okay, so here we're going to have BC. BC is √3 times h. This is all over cos beta. Then we're going to have √3 times h times 2 sine beta times cos beta. In fact, what happened to this 2? Hey, I kind of dropped this 2. That was another mistake. Oh God, I'm feeling like I am asleep now. This is cos beta, okay. Cos beta takes cos beta. Then we end up with, okay, this is not needed. So this means DC is going to be 2 √3h sine beta. Therefore DC is going to be the square root of 12. Because when you place the 2 inside, it becomes 4 squared times 3, which is 12 times h times sine beta. I guess in lele manje. Pelan lalang, Oh, I wonder if this video is going to be up on time. So it didn't have to come up here. But again, you can see this technique almost worked, you see. It's just that we did some crimes, okay? All right, okay. Maybe let's show this reversal nicely. It looks chicanery there. So we're going to say this is 2 squared times 3 times h sine beta. Therefore, DC, this is going to be nicely the square root of 12 h sine beta. Remember, important steps, guys. So that if a mistake happened like we did, imagine if we just didn't see that mistake, and let's imagine we were writing an exam and that happens. You'll still score marks, okay? You'll still score marks, guys. So this one is one of those crazy questions that you guys need to know how to handle. Right, so to write the sign rule in terms of the triangle is mark worthy. To use the identity here, cross multiplied, because I just did it here already. And that's 2. And then to reverse this, perhaps at this step, that's 3. So we've got how many marks now? 1, 2, 3. Yeah. The co-function here to this 4. So 1, 2, 3, 4, 5. Parallel. And 70. And 70, guys. And 70. So I'm happy. Now, our friend, the troubles in paradise. Okay, how many questions? Not so many. Okay, let's go to it quickly. Question 8. We are told DE is the diameter of the circle having center O. So if this is the diameter, this means this is the radius, this is the radius, and that is the radius. Perhaps let's use a different notation. And that's a radius too. So if that angle is x, this one is x also. Angles opposite equal sides. That's what we have so far. Otherwise, that diameter doesn't help us in terms of the angle in the semicircle. Okay, points A, B, and C lie on the circle, so they are concyclic. Now, AC is parallel to DE. Okay. AC is parallel to DE. Okay. Right. So meaning co-interior angles would kick in at this stage. Okay, we'll see. And then AF is equal to FC. Now we know that when a line from center goes to the midpoint of chord, it means this is 90 degrees. Okay, line from center to midpoint of chord. Okay, that's something. That's something. And then we're told that ODC is X, so we can see it. Now, calculate the size of F2. You see now, this is where the problem comes. Calculate. How? Because we can deduce it. Madness. It's just a determine, guys. So let's just help the examiner here to find the right word. This one is the good one. Can't just say calculate everything. This one doesn't need a calculation. In fact, there's no calculation we can perform here. So we just know, guys, that F2 is equal to 90 degrees. Why? This is the line from center to midpoint of chord is perpendicular to the chord. So statement and reason. No calculation here. So this is one of those crazy questions. Here we disobey the examiner because he's not asking a relevant question. He's being ridiculous, or she is being ridiculous. Right, because we have to be politically correct, you know. We can't say he and neglect the she. Yeah. See, politics, guys, are going to cause us to have headaches. There are certain things that are easy to just refer to a he. Because, you know, the she's in this world, they don't like to be wrong. They always want to be right. So it's nice to say he, right? Because they love it like that. But when you talk about correctness, whoa, they would kill you. They want in. Okay. All right, okay. Determine in terms of X. By the way, she's are the special people, okay? Those are brilliant people. Way better than the he's that we are. We are the problem as the he's. No matter what we can use to justify, the she's are the best people because they do things, man, you wouldn't believe. I mean, those people can carry a child and study at the same time, score distinctions, and raise that kid and still manage a career and become successful. We, on the other end, get easily distracted by unnecessary things, and when we are truly distracted, we just fumble and fail. Very few men can stand strong when things are hard and tough. Many give up, especially modern men. They are the version of the so-called women. I don't know of what generation, but anyway, women of this generation too are a little, in fact, they are less virtuous than those of the past. I mean, our mothers were the best, guys. Our grandmothers were the best. They never fought any battles. There was no need to. They just understood how things work, and they just capitalized on what works the most for them. But now women of today want to correct everything, and that's why they suffer all the time. Because there are certain battles women are not going to win, especially when their adversaries are men. It's unfortunate. It's nature that dictated that law. It's the law of nature. It's not anybody else's law. It's the biological law. That a man would hold some advantages biologically against a woman. And there's nothing a woman can do about it, okay? Just have to accept it. As well as we know certain powers that women have, we cannot have. I mean, men by 75, they are dead from a heart attack, even if they didn't have hypertension. It's because the bloody testosterone never goes away. Don't hear feminists talking nonsense and saying a man goes through menopause. What rubbish is that? Where have they had such nonsense? Yes, some people with diseases in their factories for, the bullets. If the factory for the bullets is somehow buggered, obvious, it's not going to work, okay? But there's no menopause for men in general. It doesn't happen. Even if you read in the Bible, guys, you will see that abantwana bakaRuth ngabantwana bakabani kanene ababajika umuntu wajika wabalilitye. One of the daughters kabani kani wangibani la tata khona umuntu wajika kodwa wabalilitye wabayityiwe. Do you guys read the stories of the Bible? Yes, there was someone who turned into a pile of salt or something by turning back. But the daughters of that man, they saw that their father is old and he's not going to make much of his life. They decided to keep his memory by sleeping with him. So the issues of incest, guys, are even in the Bible for some reason. They slept with their father and they fell pregnant. And the man was old and tired. So bazithathela ngenkani lapha nakulamadala. Bazithathela. So now ngicela iphi menopause lapho. Anufunda ubudenge bantwana ndini. Lokho nifunda nonsense. Wesothi abantu abatsha ngoku abadala kunani. They are busy doing crazy things and saying crazy things and not making any sense. And they are teaching kids to be a disaster. You know what I see which disturbs me the most? A parent using their kid to trend on social media. That for me is such a disservice to that kid. Because that kid will never fully grow knowing what is to be a child and not have, the so-called self-esteem, because theirs is going to be defined by how they're accepted in social media from the word go. Before they even develop trust in what they can do despite others, they're already going to be living a life that is there to please people. Why people do these things? Why do you hate your kids so much? You use them to trend. Really? It just shows also that those parents have low self-esteem anyway, because they need approval of what they should see as a beauty just before them, and they don't need to show others others will find out. There's no need to show them. And the second thing, some crazy people, they get to know where your child is and they know what that child can do. And then the kids get stolen. And you wonder why, because you're advertising them. But what I hate though, despite the stealing, because that one is a bit debatable, but what I hate is that you are creating kids with no temperament whatsoever. Kids who will have no self-esteem, no identity whatsoever. They will live by the standards set out by people they have never met, that they should never meet, people who are insignificant in their lives. And the very significant people, they themselves are weak. They are just weak. I don't understand a parent who uses a child to trend, truly. I really don't. Even these teachers, these young teachers, they're disappointing me. They are trending on Facebook using the kids they're supposed to teach. And when they trend, it's not anything educational. I'm wondering, did they gain consent from the parents to even post such things in public? And what those kids say when they are at leisure, Is that even correct? Why is the Department of Education, though, taking these things lightly? Because for me, there should be a heavy hand to those teachers, especially at school, even if it's not at school. Remember, guys, if you're a teacher, you chose an image of a role model of a nation, and you cannot tell me that it's my life, I can do whatever I like, then choose something else. Go do modeling, something that's going to put in the public eye's view. Can see you naked and not naked, semi-naked, whatever. Go there. Don't become a teacher. Because if you're going to be so personal about what you stand for, then go away. We don't want a teacher like that. We want a teacher who is a visionary, a teacher who is a virtuous teacher, not someone who's just looking for trends, using other people's children wrongly so. Because trust me, Seninlozi said, association brings about assimilation. These things start small and little, but the disaster that's coming tomorrow, guys, we are not ready to face it. Trust me, we are not. People started trending kids who are disobeying their parents and talking trash. First, they laughed. This one is crazy. There were parents like that who get excited when their small child is insulting people. And everyone is laughing. It's like ngavele ndifike ndikhalise isabhokwe nje ndibethe zonke lezo zinto ndizihliphise ndizishiye zidlakadlaka because singudoti vele sendizithathe ndizilahle emgqomeni. Kind of people are those. Now jonga abantwana babulala abazali ngoku, because ngabantwana bakhule besinekela bebhayiza apho. Umntana akazi phela bisithuko sithetha ukuthini, uva nje ibizwa le nto umuntu xa enomsindo naye ayibiza putsek yathuka uzakuthuka mthuke bani putsek ngomso ukubamba ngewashi umntana akuxabele ngezembe. Zathi umntana ungenwe idimoni, nguwe mzali idimoni. Ubufake umntwana amafofunyana ulibele umsinekela lapha ngoba lokusemnandi kuselula. Ulibele bangomso ukhulisa inyoka endlini ezavele constraint sani python ihle mayisencinci lanto and cute and all kind and quiet. Starve it uzobona wena. Eza ku-constrictor ikugwinye. And that's what's happening. I'm not happy with it. I'm not excited. Actually, it's sad, but in retrospect, guys, most of these people have created those monsters in their kids. Umntwana othi mayekhala athuliswe ngesweet. Kind of a parent is like that. Ungakwazi uthi emntwaneni, hey wena awuzoyifumana le nto oyifunayo ngexesha lakho. Kumntwana into yiyo uzawumamela ulinde ixesha lifike. If uyafundekela nto isikithola isibhaqo thina sivele sibethwe thina ndizavele ndikubethela into uzavele lilela into ekhona ke ngo bese kuqhala isibhaqo once. And xa kugqiba kukhala eso sibhaqo uyafundekela ukuthi asifundekela wena uthuliswa ngesinye isibhaqo. Ngokunina abantwana benu zichepisi ziyanwebeka nje, like ichepisi zincamathele ezinweleni and ayisuke, funeka uzichebe inwele ukuze uyisuse. nanizoluza kangakanani before abantwana benu babe semcimbini, guys. Hey, watch out, Nina. I'm worried about you because you're not raising kids who are leaders of tomorrow. You're raising monsters that are going to chow you first before they chow the outside world. And that's not nice. Okay. Andikelibe kancane. Saduhlekela ukubhanqa abantwaneni. 2, yekani ukuzitrendisa ngabantwana, guys. Khanike nibe ne-self-esteem umuntu akha-trend. Kambe bakhona abanye abazali bekade betrendisa abantwana all along. Kushuthi bebe-build i-momentum befuna ubona uba uzawuthandwa consistently na. And then after that bona sekezivezile unini. Abadala is-aram besingazi uba masizasiveze kanjani ebantwini. Ngobona sekeziveza kancinci kancinci. Qamba we. What? An umgquba wabazali. Ndofanele siyigalele emasimini basityale phezu kwayo. Because come on, guys. Hi man. Hi. Man. It must stop. Otherwise, I'm gonna stop it. Don't ask me how. You don't wanna find out. Anyway, guys, let's go. I think I've taken my break like that. That was a commercial break. Now, determine in terms of x. Giving reasons, the size of the following angles. O2. Right. How do we find O2? We saw it. That particular triangle. Okay, we saw it. It's an isosceles triangle. Now we're going to deal with that one. Nice and easy. So we're going to say in triangle. DOC. Doc. Komiso me dogotela. What are you? Are you gerachte? Are you cutting people there? Yes, I'm the geracht. Is it gerachte? What is that actually in Afrikaans, man? Tell me in the comment section. I'll be happy because I'm gonna use it. Alright. Right. In that DOC triangle, what do we have? We know that essentially OD must can be equal to C. You must watch. These are the ready. Right. So this implies that angle D must can be equal to angle C1. Why? These are angles opposite equal sides in that triangle. Because it's just not angles equal sides where in a triangle we stated which one. Right, now everything is good. We can say but, or we can say then. We know that angle D plus angle C1 plus angle O2, this is equal to 180 degrees. This is the sum. Oh, my hand is tired. Sum of 3 angles of a triangle. So a lot of stuff here. But some questions are unfair, guys. Look for 2 marks. Look at this. Look at this. This is x plus x because it is a lingana lesia. So this is O2. See, my O2 is like a 0. Goodness. I ngeke bafethu ngikhathele. I guess no muchmas. Hi man. This means angle O2. Again, look at my O. It looks crazy. Angle O2 is gonna be 180 minus 2x. Yeah, that is the one in terms of x. So gamana. Don't go. Hela gabi. Tlontlaila hampe jwale ntsebela kae ntse nghetla mana ntsebela kae re le ngaela gona he ha re le bina he mahaeng kwana la gona mbana kae ona mbana kae o tla go ya ntseba ona mbana kae ka bona unghetla Kabala ungetla etla tlaro ya ntseba nna ona mbona kae I think this one ona utlaro yanzibana. Unambonagai kabuna unjeba. Kabuna unjeba jeba utlaro yanzibana. Unambonagai, unambonagai. Unambonagai utlaro yanzibana. Unambonagai. Bare mphatlalatsane na le diameso. Re bonaga na re busile. Re gona o tswa re etse mathematics, ke yona fela ntho re batla mafatshe mona. Utlwa ke yona ntho ena ba re batle size ya B. O guys jwale B ke yane. O itoletse man o thotse o itse tu. Ha bue ntho tse ngata. Okay. How are we going to find this B now? We can see something. That this angle, you see, this angle here, us two can be equal to 2 times that angle. Right, angle at center equals 2 times the angle at circumference subtended by this arc because there is no chord. Okay, all right, okay. And we see that this one is 90 degrees. Sometimes you can use vertically opposite angles or even angles on a straight line. Who cares? But we can say vertically opposite angles. So this one pushes us into this nice corner right here. You see, Mos. So this triangle is going to be the ultimate. You see. A bit of planning, folks, is going to give us what we want. Then we're going to find that size of B. Okay. It looks nice and dandy like this. So we're going to move from one triangle to another. But how will we find that O1? Yeah. Hey, this O1 is doing the O1 things too. How do we do the O1 things? Ke batla o tsheya jwale hobaneng ha ke tsebe re tlo fihla jwang mane ke hole mane matsoho a ka a fihlele mane ha a fihlelle mane jwale ke tlo ingwatha jwang ntwena ke tlo ingwatha jwang papa ena hle ke a batla ke nahana hore re tlo etsa dintho tsa sekgowa mona re tseba hantle hore angle ena yona ena C1 plus 2 ke di co-interior angles ka baka la di parallel lines tsena. Okay? And then ha re qetile mono re tseba hantle hore ena re ifumana hore e tshwana le yane. Ho tsho hore re tlo kgona ho sheba angle ena in terms of x. And then ha re qetile mono re tlo kopanya this f2 at 90 degrees le yona ena. Re tlo fumana O1. Then ha re qetile ka O1 re tlo tse re pota wa bona ya ke yona hybrid ntwena wa pota mona wa theosa wa nyolosa wa dula wa yema wa matha wa bona wa iketla ke ntho tse ngata fela ka nako le 1. You will put up with it. If you don't want to put up with it, it's gonna put you up on the wall and nail you like our Lord and Savior. Except that you will not be hanging there in grace like he was. You'll be hanging there like the thieves that were hanged next to him in shame. Huh? Yes, and yes. All right, guys, nonsense aside, we need to finish this paper. I'm tired too. So let's get to business now, folks. We know that, okay, all right, okay. We understand that angle D plus angle C, C1 plus C2 should be equal to 180 degrees. These are the core interior angles. We always mention the parallel lines, right? DE is parallel to AC, all right? Because co-interior angles, when there's no parallel lines, they're not equal, okay? The only equality comes with the parallel lines. So don't say things that I didn't say, ne? Yeah. So now D was X and C1 was also X plus C2, which is what we want. Is 180 degrees. God, I'm feds. Those are alternate angles, man. Hi, man. Why am I suffering? Damn it, man. This one, man, is like this one. These are alternate angles with those parallel lines. Why am I suffering? Dash it. We know that C2 is going to be equal to O2, man. Hi, man. Don't be lazy. You see, now tiredness is working on my nerves. So these are the alternate angles with essentially DE parallel to AC. See, the parallel lines are giving us the alternate angles that are equal. Only parallel lines. When cut by the transversal, which is going to be OC here, and the transversal must be a straight line, right? Alright, now we are in a good position to find our O1. We can say in a triangle, okay, we can just say also, we know that O1 plus C2 plus F2 should give us 180 degrees. This is the sum of three angles of triangle OFC, right? Right. So this implies that O1 is what we want, plus C2, which is going to be 180 degrees minus 2x, plus F2, which is 90 degrees, is going to be equal to 180 degrees. Hey, when? Juan. Watla honketsa. Skabapala so, man. Near. This is not looking right, This is not looking good at all. Hey, when? Kwenzeka ntoni ngoku? I don't like what I see, guys. I really don't like what I see. But there were other ways in which we could do this. If this is 90 degrees, this means this angle also is 90 degrees, ne? Let's try and see what that could give us. Now from 90 degrees, this is 180 minus 2x is equal to 90. So it's already going to give us a negative angle. Of course, we can't avoid it. So it would give us what we see right now, because we know that this is going to go. So this means essentially, therefore, angle O1 is going to be 2x minus 90 degrees. Okay, it is what it is. Ne? So we leave it like so. And then we go back and say, okay, what are we looking for again? Angle A. We can say then, in triangle AFB. Yo, guys, we are mutating like the Delta virus corona. The coronavirus. Right. We know that 2 times angle A should be equal to angle O1. Angle at center equals to 2 times angle at circumference. Right. For that arc CB. So this implies that 2 times angle A is going to be 2x minus 90 degrees. Therefore, angle A is going to be x minus 45 degrees. Okay. Not bad. It's good, Moss. It's good. It's nice. It's good. Now, once we get this one, folks, what are we looking for? Angle B. We can say then. Can say essentially, oh my Lord, didiniwe yazi le nto ngoku. Also in this triangle, we know that angle AFB is equal to, let's start doing the right things, guys, is equal to F2 equal to 90 degrees. These are the vertically opposite angles. Okay, for 6 marks, we need to sing. We sing a song. So, which implies that angle B plus angle A plus angle AFB is equal to 180 degrees. This is the sum 3 angles of a triangle. Yo guys, I am so tired. So angle B plus angle A, which is x minus 45 degrees plus 90 degrees, is equal to 180 degrees. So therefore angle B is going to be 180 minus 90. That's 90. 90 plus 45, what is it? Is 135, ne? Yeah. So this is going to be 135 degrees minus x. Oops. It is the one. I don't find any other. I don't find any other. I don't find any other. So, guys, this thing is working on my nerves, man. I call. There's a tavern. Because, sorry, excuse me. There's a tavern in Kusezwelitana neba. Ogqithiramafule ne. Siyamatatiela. Khona indawo pha before kwaMkonyana. If I'm not mistaken, eh? Is it before kwaMkonyana? If we are greater kwaMkonyana, ne? Then konje lesikoti impati tavern indawo nqoqba gqithi kini raport kanene owathi khona lapho man khona kodwa nje lapho ariki isikoti impati tavern that one itlo upate ke uzwetsa ke maths ehentwane liyona hayi it qualifies to pata batho yabapata ibile lena yampata wabona. It's a powerful statement and the reason, powerful deduction. So essentially sum of 3 angles of a triangle and all the shenanigan is not good. So that's good. The final answer, I think the value of 01 was key. That one is good. So 1, 2, 3, 4, 5. Maybe any other statement, guys, that you think works should work, ne? All right, so that's the first 10 marks. The last one was not so friendly, but not so bad either. Just needed a bit of strategy. Okay, now guys, I'm not gonna do the proof. We're gonna do it in the class. Okay, when we meet 9.1, I'm gonna do it in class. I'm gonna jump straight to this one for now. Okay, right, so So 9.1 for the onlooker, guys, go to the textbook. There's no need for me to repeat what is in your textbooks. I know you guys ignore your textbooks and prioritize what you see here, but it's not different. If it is in the textbook, I don't understand why I should do it. The teachers also, before they started doing any questions on this, they start teaching this thing, guys. Come on. Unless you're saying you don't understand the other aspects, then I can highlight those. But for now, thank you very much, comrades. That is your homework. In the diagram, triangle PQR with ST parallel to QR. Okay, we can see that. K is a point on QR and is joined to T and P. PS is Y. SQ is Y minus 1. TR is Y minus a half. Where is it? There. Y minus a half. Then PT is 2 over 3. So it's basically 3 halves of Y minus 3/4. Okay, that is done. So we can see that in the main triangle, this main triangle, there's one side drawn parallel to it. So proportionality theorem can help us here, right, to find the Y value if at all it's necessary. And yes, it is. So let's see 9.2.1. We know that we're working in triangle PQR. So we can say here, to solve for Y, we know that PS over SQ should be the same as PT over TR. Okay, this is the prop theorem. Remember, it only works when we have one side drawn parallel to the third side. Otherwise, it does not apply. Okay, be very careful. So don't just write prop theorem without the condition. Now PS is Y divided by SQ. This is Y minus 1 equals PT. This is 2 over 3Y. Oh God, what is this now? This is 3 over 2. Y minus 3 over 4. All of this shenanigan is divided by essentially Y minus 1/2. So it's a very nasty kind of a thing. Okay, we can cross multiply here so that we can sort this out. So we've got Y into Y minus a half equals Y minus 1 into 3 halves of Y minus 3/4. FOIL method, we get Y squared minus a half of Y equals, here we're gonna get 3 over 2Y squared minus, now we've got 3 over 4 minus 3 over 2. Okay, so this gives us a minus 9 over 4 Y plus 3 over 4. Okay, good. So let's move on. Collecting like terms. So we're gonna say 1 minus 3 over 2. So 1 minus 3 over 2. It gives us minus 1/2 of Y squared. And then we're gonna have minus a half. Why did I remove this one? Then we add 9 over 4. So this gives us a plus 7 over 4Y. Right, when we move that to the other side, and then we can move this last one. It's going to be minus 3 over 4. Equal to 0, because this is nicely a quadratic. So we can divide by negative a half. What do we get? Y squared minus. So 7 over 4 divided by 1/2. So this gives us a 7 over 2. Ooh, I thought this was going to go away. It's not going away. Why? Oh, Lord. It's not going away. And then let's see. 3 over 4 divided by... What's that doing? Divided by 1/2. This thing looks scary. So we still get a plus 3 over 2. okay, equal to 0. Remember, to get rid of this, we can multiply again by 2. Okay, we get 2y squared minus 7y plus 3 equal to 0. Now let's try to factorize. Okay, guys, a lot of manipulations. I'm just lazy to use the quadratic. 3 is going to be minus 3 and 1. Yes. Therefore, y is equal to a half. Oy is equal to 3. Now, both of these are positive, so we can accept the values. But now the question said the value of y. Now, we need to think about it. If y is a half, do you see that this one would not make sense? It would be 0. And that's not possible. There's no length that can be 0 and it's drawn. So this means here we need to make a conclusion. Guys, this paper was the devil, I'm telling you. The conclusion is that y must be 3 because it can't be a half. Because that distance would not make sense. Yeah, this one was a devil paper. Trust me. Not that the people who made it are the devils, but this paper was the devil, okay? We are dancing with the devil here. But again, it's nice to do this. Proportionality theorem, substitutions. Guys, the gymnastics here, I think the final factorization and the answer. And of course, maybe rejecting this one would be good. 1, 2, 3, 1, 2, 3, 4. Well, maybe this, we can add the mark here. We can, to make it the 5th mark. Or we can consider this rejection because it's an important rejection, I suppose. So it doesn't matter after all. Once we've done the job, guys, we move on, okay? I don't want this video to be long, but it wants to be long, right? It wants to be long. So it's very important, folks. It's very important to do the things. You know, guys, I'm tired and hungry and I want to ride my bike though. Must remain. So let's do. It says now prove that if PKT is equal to angle Q, there has to be a cap here. So PKT, so this angle, if that angle is equal to angle Q, now we need to prove that PSKT, this one, we need to prove that PSKT, so this is a cyclic quad. Of course, we need to think about our bow tie situation there. Okay, so automatically we can already see that that angle is equal to that. These are corresponding angles. Therefore, those two are angles in the same segment. So that's good. Oops, if only I had enough space. Okay, let me write it here, 9.2.2. We can say here, well, first and foremost, angle K, let's just say PKT is equal to angle Q. This is given, right? Also, we know that angle Q is equal to angle PST. These are the corresponding angles with ST parallel to QR. Right. Now this concludes that essentially PKT is equal to PST. H is equal to angle Q. If this is the case, we can say therefore indeed PSKT is a cyclic quad. Reason being, this is the converse of angles in same segment. Okay. Normally we get told this is a cyclic quad and then we can say angles in the same segment are equal. But this time we're doing the opposite of that, or the reversal of that. Okay. Otherwise, folks, this one was easy. Statement and reason. And then that link, okay, maybe the reason for the last one. Okay, yeah, easy. Again, guys, this 12 marks was not really bad because the proof is 3 marks, 5 marks from the textbook. And then this next 7 marks was not bad. Now let's get to the one that has the suplexity in it. You know, my suplexity is always going to be that guy. That guy, no matter what, is always going to be that guy. So question 10. Right? In the diagram, D is the center of the circle. Okay, good. If D is the center, this is the radius. This is the radius. And this one, the whole side to this point. Okay, those are ready. All right, and of course, BF is a tangent to the circle. So at B, so of course the 10 chord theorem. So we've got a cyclic triangle here. 10 chord theorem immediately kicks in, and of course 10 perpendicular to radius. 10 perpendicular to radius. Okay, this one is gonna do me bad. Let me make it small. There. So the tangent perpendicular to radius. Okay, good. But if we know that ADB is a straight line, this should also be 90 degrees. Angle in the semicircle, but we don't know about this as yet. Let's not do it. Okay, we told C lies on the circle to form chords AC and BC. Okay, so these are the chords. D is joined with F. D is joined with F. Okay. And BE is equal to DE. Okay. So this means this angle here must be equal to that. So those are the angles opposite equal sides in that small triangle. All right, so that's what we have. So we're not told that this is a diameter, so we're not going to assume, unless of course we don't have a choice. Okay, so let's get to business, guys. 10.1 with 10.1.1. I'm really tired. I don't have the energy anymore. Now it says we need to prove that C is equal to ABF. But I feel like there's not enough information about this. How do we prove that, guys? Because we need to know that AB is a straight line. Somebody has to tell us that. And there's no information on this. So we're going to then work on the assumption. We're going to say, well, assume ADB is a straight line. Now this is already a negative, because the moment we assume, honestly, we have our own question created. I don't know why. Why are you guys doing that now? After doing so well, this paper was bulletproof. Now this? Hell no. Anyway, well, guys, we don't have a choice here. We're going to say, well, one thing for sure is that we're going to say, well, we can say angle C is equal to 90 degrees. So we can say angle in, not angles, but an angle the semicircle. Assuming ADB is a straight line. Otherwise, we don't have a choice, because even if we try to use sum of 3 angles of a triangle, we would still have to see that this is a straight line. At least they should have mentioned that ACB is a triangle. Then that would mean ADB is a straight line. So unfortunately, we don't have a choice. And you write this to spite them, so they know they didn't do the right thing. But of course, you might be victimized for it. Okay, be careful. Say it nicely. Don't come with an attitude here. You're gonna die. So we know that also D, B, F. In fact, let's just call it the way it was mentioned. So ABF, of course, if we say ABF, we're assuming that this is a straight line. ABF is going to be equal to 90 degrees. Why? This is the tangent perpendicular to radius. You can say therefore C is indeed equal to ABF, because each is 90 degrees. Nice and easy. All right, so this is 4 marks, guys. Statement, reason, and this is a deduction thereof. Okay, cool. So 10.1.2 says we need to prove that DF, okay, once we see ratios like this or sides multiply, we need to first find where those sides are. Where's DF? Now DF, come on man, select DF is here. Okay, that's DF. Where is BC? BC is over there. Okay, maybe let's just highlight it instead so that we cannot have too many clutches. And remember, we proved now this is 90 degrees. We never describe an angle that is made up by not a straight line. So yeah, so this is 90 degrees. And there's BC. So BC is over there. All right. So we see you, we see you, we see you, we see you. So basically, it's the side of triangle DBF and the side of triangle ABC. Now let's look at the next one. AB. Where is AB? There you are. So guys, this is always easier to do this because at times it gets overwhelming where to start. So to find the sides that are relevant, it makes life easy. And then we've got masithatha umnyamana, sithi umnyamana uBD uphi. Where is BD? Now BD is here. So this means we're definitely looking at the small triangle DBF, because those are the sides belonging to it, and the big triangle ABC, because those are the two sides belonging to them. And obviously this works with similarity usually. So we can handle that business, right? Right. So let's see what is cooking here. So we're gonna say, well, in triangle, let's start DF. We can say here this is DBF. I don't really care on how I name this, but perhaps your teachers may tell you that you need to name it such that and all that, whatever, guys. What happens when someone decides to trick you? Will you still say the same thing? As you can see, these question papers are becoming very challenging. So you might as well know everything, right? Okay, triangle ABC. You can see we're comparing those triangles. First and foremost, we know and understand that from DBF, we know that D2 is going to be equal to B2 in the other one. These are angles opposite equal sides of triangle DBE, right? Given DE is equal to BE. Okay. So if the reason has to be comprehensive, guys, it has to be. So that's the first thing. Okay, those two are equal. The second thing, we understand that we proved that essentially the angle ABF is equal to angle C. Right, we can say proved above. Now, guys, the third set is not important in my opinion. I mean, you can say it, but it's automatic, right? So if we have compared those ones like that, so the remaining angles are going to be equal, meaning this angle is equal to that angle. So those are the remaining angles. But do you really need them for this? Not necessarily. So here we can just write triangle DBF is indeed similar to triangle ABC. Reason is angle, angle. The third one is automatic. So therefore, if these are similar, then we choose the sides. I'm going to start with DF for the small one. DF is opposite that angle 90 degrees, and the side opposite the 90 degrees on the other one is AB. It's always the sides opposite the equal angles that make up the ratio. Then I go and find DB over DB is opposite F. F is equal to A, and the side opposite that is BC. Okay, very important. And then of course we can just say proportional sides of similar triangles. Okay, very important. So just cross multiply from here. So we can say therefore DF times BC is equal to AB times BD as it was written. In fact, let's write it as it is written, BD. Always try to write some things as they are written, of course, to try not distort the whole thing. But hey, we can change positions as we want. All right, guys, so this is cool. This is cool. This is cool. Yeah. Maybe we can say statement and reason there, 4 marks, because everything else, guys, is there, but it's part and parcel of the work, but it's not such a strong component of the work, okay? Let's get to business again. 10.1.3. We need to prove that E is the midpoint of the circle passing through D, B, and F, okay? So it means there's a circle here. Right, so we've got a circle passing. Okay, right, so let's just adjust this one so that it fits nicely. So that is the circle. Anyway, we are done with this one. So sometimes some things you may have to get rid of because they will interfere with the work. We've used those, we no longer need them. But if you can't, leave them. So we want to prove that essentially this is the center of the circle, because the midpoint of the circle is nothing but the center of the circle, okay? So how will we do that? Of course, this was point C. Well, we can see that essentially this angle equaling that and this one equaling that. So these two angles are equal. So this makes us a deduction that this side is going to be equal to that side as well as equal to this side. Right. Those are the sides opposite the equal angles. And that is the case. We can clearly see that then E is the midpoint of DF. And if E is the midpoint of DF, it then means that must be the center of the circle, because that becomes the diameter. Another way of looking at it, but I don't think it would work. Yes, if we say this is the angle in the semicircle, we can only say this diameter would be DF, but to know that E is the midpoint, it would not help us. Okay, let's not explore that. So 10.1.3, we can say, well, first of all, we know something. That in triangle, we want to use this triangle. Or maybe let's leave it alone. So, okay, fine, we're just going to go freestyle here. First of all, we know that angle A is equal to angle F, okay? These are the corresponding angles of similar triangles in question 10.1.2. Right? We know also that angle A is equal to angle B3. This is from the 10 chord theorem. Right? 10 chord theorem. I think I'm seeing something move around here. Eh? There's lots of insects in this place. Drive me crazy. Anyway, from here we can clearly see that essentially B3 is equal to angle F, because each is equal to angle A. If this is the case, we can then conclude that BE is equal to EF. Right. These are sides opposite equal angles in a triangle. Right, avoid base angles, because the base can be any side. It may not even include the angles that are equal. So what? So this is why that is discouraged, because the base is any side the triangle is put down on. But which one do you decide is the base? You don't. So the base angles doesn't count in grade 12, because we want to be precise. So we don't want to give a narrow answer when it can be wide open. Now from this, guys, we can say, therefore, again, we understand that EF must be equal to DE, because we know that it was given that BE is equal to DE. Okay, so if this is the case, guys, we can conclude, therefore, that E is the center of circle. DBE. Right. So that is how we do that one quickly. So we were scoring how many marks? 4 marks. Okay, maybe statement and reason. This one, statement and reason, is quite powerful. This one is good. And the rest goes nicely. But again, we can just say, okay, maybe statement and reason there. I think that last statement is more strongly associated with the answer. Okay? Right, 4 marks. Now let's deal with the suplex. Let's deal with the suplex CT 10.2 and cut this thing. So 10.2 says we need to prove that 1 over b squared minus ab squared. So what is that, guys? Well, what I can tell you is we need to think now. Now, since this is the center, it also means that EC is also the same because it goes to the circumference of this circle, right? But let me wait a second. There's no one mentioning that. Maybe let's leave that alone. Because we don't know whether C lies on this circle. We were told only this goes between B, F, and D. So C may or may not be a part. So let's leave that. So that one doesn't work because we can't really use it. But from what I can see here, guys. So from what I can see, that triangle, if I look at this denominator, it's a right-angled triangle. So I know that AB squared, right, the hypotenuse is going to be equal to AC squared plus BC squared, right? This is from Pythagoras. But for us to end up with a BC minus AB, what happened? So it means we transposed this. So it means AC squared is going to be equal to AB squared minus BC squared. But if we multiply by negative here, which is crazy, but yeah, it looks like it. So we're going to get minus AC squared equals. Then when we multiply here by negative, BC becomes positive. Then AB becomes negative. So this, for me, says we are using that triangle for this business to get there. So at least this one I know is coming from finding AC. So this is this length right here. Maybe let's just take it. So this is that length when we look at it negative. And the nice thing is that this answer here is also negative to suggest that we manipulated things in that regard, okay? And then we look here. We look here and try to find some sense here. We've got FB. So FB is this length. And then we've got AD. AD is that length. Maybe let's use a different color. AD is this length, which is also equal to DB, right? Because those are ready. So these ones are ready. Okay. So AD, FB, so we're likely using these triangles again, because you see what is this? BF is that small triangle that we proved above, and then we're looking at that one on top. AC is part of it, and then AD perhaps comes up from that diameter in a way, okay? And then we've got EF. So guys, question is crazy. EF and AC. So AC is coming up again. So obviously EF, if we look at it in terms of the two triangles that we proved similarity on, EF is basically half the size of DF. Okay, so basically this is what we have. And DF here, we got it somewhat. So maybe we might have to use that. Maybe not. We don't know. Whew, this one is hard. This one is super duper hard. Okay, let me see. Let's start with this triangle. Since we see that there's some AC here, let's try to use these triangles. We know that AC over... Now AC is opposite that B2, ne? But we saw that B2 was equal to D2, and then the side opposite that is BF or FB. So this one is coming out. So we can see that there's AC and BF, okay? This must be equal to... Now we need to be a little bit strategic as well. I'm looking at DF. I think DF is part of the puzzle, because for us to get some AD, I'm not sure where this AD came about, but if let's say DF, by the way, we started with a big one. Let's say, for example, we choose, because there's AD, which seems to be coming from this AB, right? So I'm going to choose AB here over. Now AB is opposite the right angle, and then the right angle is that, and the side opposite is DF. Again, we can just say these are the proportional sides of similar triangles in 10.1.2. Okay, we're still using those, but we're choosing the different sets of sides. And then from here on, folks, I'm kind of thinking FB is there, so we can cross multiply here. So this implies that AC is equal to AB times FB, all divided by DF. We're not going to change this. Now we don't have a DF here. We also don't have an AB, but we know that AB is basically 2 times AD, from that being already. So we can say this implies that AC is equal to AB, we just write 2 times AD times FB, all divided by DF. We want EF to come in, so DF is also 2 times EF, then times, okay, nothing. So this is 2 times EF, okay? So we know that those are ready, so we don't really need to justify this. And then the 2, because we're doing multiplication, takes the 2. Then we have a situation that AC is equal to AD times FB, now over EF. Okay, now that part is sorted. But we saw that we had a minus AC also somewhere in the BSAG 8, you know. So how did we end up there? Yikes. You see, you know, these questions. But sometimes what we have above, but what can we use here? Is there anything? We've got AD, we've got EF, we've got FB, but there's none of those there. There's none of those, so this one is not likely to assist us. Usually it does, but it's not. So we need another equation, but now to get AC cubed. This one is AC cubed, and we can see this one is minus AC squared, essentially, from the above. So how did we get AC cubed? Yabona kabo suplex city basinyanyisa thina sikhathele, guys. What do we do? Hebana ayiveli phela lento, because that ratio we proved in 10.1.2 is useless for us. It doesn't have anything of what we want. Say DB or BD is part of AD, so it's not gonna get us much. If we include that, we're gonna end up with a square on the EF. Yeah. What is this now? But since, guys, there's already a strange thing, my thinking is that, remember, guys, I always say, sometimes in maths we can divide by anything that we want, as long as it takes us home, because for me, this is suspicious. We will not be able to get an AC cubed here unless we force it. Ifana nechair mengafuna ukuvuma, uyiphula ingalo, uyijija i-wrist, you twist the wrist, the girl is gonna get you the attention you want, okay? So here mawucenga ingavumi siyayinyanzela finish and clear, because isikhathi sobe sincengancengana nabo labantu siyabafostela once. I to see kokotele. So guys, now my thinking is that we can divide by AC cubed, to get this cube right here, because what you do on the one side we're gonna do on the other. And in maths we are allowed to divide by AC cubed, because I don't know if we can get ratios that can give us a cube. It's already maybe a square would make sense, because we normally get repeating sides, but never a cube. Unless we were to get maybe to the exponent 4 again, maybe we can say Pythagoras again on something that was already squared. But a cube is suggesting this technique of saying in maths, guys, we can do anything as long as it gives us what we want. So we can say such that we've got AC divided by AC cubed is going to be equal to 80, because we're very close. We just need AC cubed, and we don't see where we can find it. So let's try FB over EF. Now when we divide this, it will multiply on the denominator. It's going to go on like that. But if you don't believe it, you can write the ratio and say AD times FB over EF. You can say divided by AC cubed over 1. This is going to be AD times FB divided by EF times 1 over AC squared, cubed. And now, can you see numerators multiply, denominators multiply, we end up there. So just in case you don't know, this is the notes for you. Okay. Now, folks, what do we do? Well, the magic start taking place. AC takes the cube and leaves us the square that we want, because we saw that we wanted a square, and essentially the right hand side is more like the way we want it. Okay, let's see, this is going to be equal to, and then AC is going to be 1, so we have 1 on the numerator, over AC squared is going to be equal to AD times FB over EF times AC cubed. So literally we have what we want. Now our job is to get rid of this by looking back. Okay, obviously for me, what we can do, as much as we did this, this looks illegal, but we can still multiply, we can still multiply by a negative throughout. Again, this sounds illegal, but it's perfectly legal, because how do we get a negative on the other side? Through multiplying, right? So we can say this is minus 1 over AC squared is equal to AD, so minus AD times FB all over EF times AC. This question was crazy. Oh, I Northwest ayidlali bafethu iyabulala. Now we can say if this is in front, we can distribute it to the denominator, because that's what we want to come out as negative, right? So we can say this is minus AC squared equals minus AD times FB divided by EF times AC cubed. Now we can say here, but we've got a story here, guys. This is an essay type. We know that essentially AB squared is going to be equal to AB squared is going to be equal to AC squared plus BC squared. We've got Pythagoras. Of course, we may state in triangle ABC. It's a right-angled triangle. So this implies that AC squared is equal to AB squared minus BC squared. So here, if we do the same thing and then we multiply by negative, wow, guys, this thing is crazy. AC squared is going to be, the BC becomes positive, and then the AB becomes negative. Okay. But again, we can multiply by anything we want. My Lord, what a mess. Therefore, 1 over. Now, AC squared is nothing but BC squared minus AB squared. When we substitute, equals minus AD times FB over EF times AC cubed. Well, imathi incinci kwedini kunathi soze siqhele kakubi icimbi izawuqhasha never. Njengoba nditshilo, guys, if intombi ayifuna ukukuvuma uyayifostela, finish and clear, okay? Thina sikhuleke iwayivele nje jiji wrist laphana iyaxoka, izawuxhumaxhuma ikunike attention. Even if it sezawuyicinga le nto ndibuza yona, that's good enough nokuthi kuphaphele ingakuphenduli. So asinoqhela kakubi imaths apha ifuna siphaphele ingasiphenduli siyibuza uba masiyithini. But again, guys, you check the memo and see how it was done. Maybe there's a better way. You know, you never know sometimes. When you look at these questions, you start to see some strange things and you're like, how do I do this? If I get a partial answer, guys, I try to force it, sometimes. But then you can check the memo. Maybe it has a better and concise way of solving. I never really hold myself ransom to memos, obviously, because I know, folks, I need to teach you the right thing of essentially knowing how to work your magic. And what happens when it doesn't come up straight up? What do? You force it, guys. Because in maths, we have a few rules that allow us to cheat our way to the answer, if you call it cheating. We can multiply by anything we want. If it's an equation, as long as we balance that, we can divide by anything we want, whatever it is, and we can choose something out of convenience. But again, you study the expressions given. For example, we have hardly come across where something could be cubed. In this case, especially with Pythagoras involved, we expect squares and single sides per se. But a cube, if it is cubed, it's already suggesting most likely we're going to have to force our hand. Even this denominator for me is a clue that we've got to force matters here somewhat, to try and get to that thing, because it looks feasibly, what can I say, it looks impossible to get, but if we force our hand in it, we can get there. So essentially, guys, that's it. I don't even know how I'm going to begin to mark these 6 marks. It's really crazy. For me, that statement is power 4. And then, these substitutions of 2 times each side, perhaps. And we can say getting to that is also a key. Then the problems begin. I can say forcing our hand here was key. So this is 1, 2, 3, 4. And then perhaps landing up there, 5. And then 6. And of course, the substitution is already covered, so I guess that's it. But again, you will check the memo for a more formal marking guideline on this. But again, remember, it doesn't matter what the memo says, essentially, folks. What matters is what we have done. We need to study this. If it doesn't make sense, then only then we can check the memo if it is available or consult anyone who may have a better explanation. But make sure that you have understood your work and you know exactly where the weak points are, because obviously points like these where we force our hand more than once, it sounds chicanery, I guess, but you see, if it works, it works, guys. What can you do? There's nothing. So this should be our 150 marks, if at all we did everything properly and legally. There's a chance for some illegal shenanigans, so especially this one. Hey guys, goodness. Yeah, the Northwest doesn't play. And I think every province should examine like the Northwest, Kids need to feel maths, okay? They need to not think maths is easy. This is not the place for children. This is the place for people who are discerning, who are dedicated, who are looking to really transform themselves. It's not a place for hide and seek here, and then you pretend you know maths, and then we ask your homework in the finals, and then you come up with a distinction and you claim, yeah, I got a distinction in maths. Get away. What distinction? Now, if you can get a distinction on a higher grade paper like this, now you are talking. Now you are talking. Is a devil. This one is the devil. This is the devil paper, guys. But again, it's very interesting in that it teaches you to then gauge how much you've gained from, studying, practicing, listening to us, the ramblers of note, the fanatics, essentially, and the teachers who are the specialists in the subject, and any other people, who can share some insights. And then after you put it all together, you sit back down, you explore your options. I mean, even these questions, the way I've solved them, you may sit back maybe sometime in the future when you're not under pressure. You may actually start to discover perhaps a clearer and maybe a fairer way of solving this rather than this cheating-like technique. But remember, in maths, guys, as we said, we look, we observe, we see what's happening, we try to force it nicely, you see. We force it nicely. Not in an ugly way, okay? Nicely. Okay, right. So even when you force the girl, right, you don't really force her the way other people force girls, right? You just force her nicely, because when she starts saying, okay, I'm going to think about it, you don't say an answer now. You're like, okay, fine, I'll come back. Right? And then mawubuya sekuyayazi uba if uyaxhumaxhuma uzayithola ijiji sihlahla, then uhlala iqonda into bazomkhalela qala kuzakwenzeka ntoni futhi xa kunje inini, qala kubuza imibuzo eyi-100. Uyayazi ke itsotsi maseyithola loo mibuzo seyazi umhlaba sewuphansi urate, yabo. Hayi vele ibe nenye i-patience yomhlaba iphendule kwasani. But come when everything is all good, ayisafuna ukuphendula noyi-1 because yesu ndihlangela ngibuza into ezininzi. Hayi, thetha 20. Ebengatshongo ngani ngala mini wayebuza imibuzo eyi-100 ezama ukucenga lapha. Nakangicengi, nyanzela finishing class. Awunganyanzeleki ngiyeka khona lapho. Right. So ne-maths ke guys, it's like this. Yayicenga, mayingacengeki, wayifostela, mayingafosteleki, uyayiyeka. Don't waste your time. Move on. There are better things to look for. You might find that it's not even that important, only to find that it's all wrong, to be honest. And then can you imagine buzawucenga nje nyaka nje uzathi masoyifumene uqonda but this one is the mistake. You see? Don't beg, man. Fostella. Manga fostelegi. Leave. Don't spend time wasting your time. Anyway, guys, this is it from me. And I hope you can enjoy this video. And I just hope you find it in time before your exams. But for my students, already we've done half of this paper. So we're going to do the last half. So I've already gone ahead of you. But I'm trying to make sure that by the end of our lesson when we discuss, you can always go back to the channel for a review, because whatever we said may disappear from you and you may want to have a look at it again. But I'm happy that the last question highlights a few things that we can force our way through, right? Please, guys, don't shy away from doing so. It is possible. Otherwise, leave a thumbs up. You can subscribe. You can share. You can, engage in the comment section. If you have any concerns or suggestions or even a critique, I can take it, okay? I can take it on the chin. I never take things personally, so don't be afraid. Even when I answer, sometimes I'm very blunt, I'm not very strategic in my answering. Sometimes you may find that my answer looks a bit chicanery and stuff. No, it's not intended to be like that, but perhaps it's just my lack of ability to express myself in the best way in the English language. I tend to say things better in my own home language, which is now certainly narrowly escaping me because I start to struggle to use the correct words in my language to even say what I say. I tend to say it better in English, even though I'm limited in English, So I've just forced myself into the world of limitations instead of plenty, okay? But again, what is disappointing is that there are not so many writers in our languages, guys. So people are just not writing properly. I kept some old books that I used at school, so when I get home, sometimes I read, and I think I need to take those books away because my nieces are messing around. They are just destroying my books with their little kids there. I'm gonna strangle those little things even. I need to take my books with me so that I sometimes read these books when I'm tired and not wanting to do anything meaningful. I just read to remind myself, because one thing for sure, I forgot to write sentences in prosa properly. My sentences are just horrible, as if I never mastered this. I used to call myself an expert of the tongue of the Xhosa language in terms of grammar and everything, literature. All of that got swallowed up by university and work and not reading regularly. So yes, I still know how to read, but to write, if you know Xhosa grammar, you will know very well that this one is a chikanari. He's trying his luck. Anyway, guys, goodbye. Before I waste your time further, this paper was already a waste of time for many, but perhaps an eye-opener for those who really love technicalities, which in essence proves them to be different from the rest, right? Otherwise, guys, you don't have to be different from the rest per se. You just have to know what to do. I see a little bug here that needs to be squashed and killed. Yes! You are gone, you bugger. Bloody mosquito. A blood sucker. You're not gonna suck my blood, man. I don't have veins in the surface, so you're gonna struggle. I'm gonna bite the skin and get the fat, not the blood. My veins disappear when it's cold, so thank you very much, comrade bloody mosquito. Anyway, guys, enjoy your exams tomorrow. Please sleep tonight. Sleep as early as 11 p.m. Wake up perhaps at 5, 5:30, 6. And you can double check a few things. Even this video, you can come back to it. But yeah, I found this paper quite interesting and challenging, and I felt it is a necessary challenge to take and also to reveal some of the issues that came during those challenges, and of course to give you an overall outlook in this paper and perhaps something that can assist you guys to work your magic tomorrow. Otherwise, all the best. Remember, you have my best interest at heart. That's why I do all this and sacrifice so much. So please don't take this for granted also. It will take you far. Otherwise, for me, is to love and live you. Now, the next one is going to be physical science paper 1. So we're going to start drilling some trial papers, maybe 2, maybe 3. It will depend on how fast I work, because we'll probably be writing physics on Friday. I'm not sure. But yeah, we're going to have to work hard. Or unless you're not writing it now, maybe that week, then that would be even better, because it will give me enough time to do the physics videos. But let's see. For now, goodbye.